Good morning, everyone. Very happy to be presenting this in front of you. So first of all, I want to thank Chris and David, who I don't see here, but for giving me the opportunity to present this chapter, to write this chapter for the handbook. When I got the sort of the assignment to do this, I looked back at the previous handbook chapters, and I tried to figure out whether the topic of climate change had actually been covered. And so there's a series of environmental chapters in the past. So in volume 2, there's a series of chapters, one by Eleanor Ostrom before she was a Nobel laureate. And the only one that was really directly on climate change was a chapter by Mendelssohn in the 2007, the volume 3, which was not really a review. Oh, Chris, I see that you're now here.
Hi, Ariel. Apologies. We've got to cross up on time, but go ahead. You've already started, please.
Okay, okay, good. Okay. So is this chapter by Mendelssohn back in 2007, which was not really a review paper of any sort, but mostly an applied paper that was about 7,000 words. So this chapter now, so volume 4, there's nothing really related to climate change, and now in the next volume there's going to be something on climate. The title that was given did not say climate change, but I made it about climate change. So even if, I'm curious to hear if the scope later on is going to be is appropriate. So this is a long chapter. This is longer than previous chapters from my understanding. So this is 30,000 words. I'm still very far away. So your feedback is going to be extremely welcome and useful to get me going, moving forward. Okay, so this is the abstract, and I'll just read it. It'll just be simple. It'll summarize what the scope is. So agriculture is arguably the most climate-sensitive sector of the economy. Growing concerns about anthropogenic climate change have increased research interest in assessing its potential impact on the sector and in identifying policies and adaptation strategies to help farmers cope with a changing climate, but also how to contribute to climate change mitigation. This chapter reviews recent advancements in the analysis of climate change impacts and mitigation in agriculture, with an emphasis on econometric and statistical approaches applied to observational data in developing countries. The chapter provides an overview of recent research efforts addressing key conceptual and empirical challenges in this literature. So this is a placeholder. We can adjust this and tweak it as needed. But it's mostly about climate change. The title is Climate, Agriculture, and Food. But it is squarely in the climate change area, which is where I mostly do my work. So the outline so far, it's basically 6 sections, but I'm thinking about that crop yield forecasting chapter, that section 5, to include it under the climate change impacts. I'm going back and forth between whether I should include this or not, and I'm curious about your thoughts. So what I'll do now is that I'll go over sections, and I'll try to discuss kind of the content of what I'm trying to cover here, and flag pieces or places where I have particular challenges thinking about which direction to go. So I think in terms of the introduction, the way that I think about this chapter is that I would like it to serve as a guide to new researchers, whether those new researchers are, say, second-year grad students, or economists who are working in a different field and want to get a sense of what has happened and where things seem to be going. So I think that's the kind of the goal of what I'd like to do. And I think it's in the spirit of a handbook, right, chapter. In terms of the topics and the scope, it's about climate change impacts and adaptation, but also about mitigation, although the part of mitigation so far is fairly thin. But I think it's important to cover these two sides of the coin. So in terms of the style, instead of trying to be like a catalog of things that happened before, I'm trying to make it more of a discussion of how the literature has evolved. right? Sort of what are the motivating research questions and how challenges in early studies motivated subsequent studies. I think that you see that over and over again in terms of guiding as a guiding force in the literature. And that includes also evolving methods and research designs. And also all of these studies are not in isolation. So some of the rise of people working with panel methods and fixed effects respond to a background movement in the empirical economics about the credibility revolution and people kind of moving away from research designs that are easy to roll your eyes over, right, nowadays. So I'll try to spend also some time on that. And one thing that I wanted also to do is that when there's any consensus, either about the whether one approach has issues that cannot be really surmounted, or findings where we are trying to find some consensus, I'll try to talk a little bit about that. And also unsettled questions or things we haven't really looked at. So in that regard, I know Tom has a recent paper in food economics, I think, that also tries to get at this point about unsettled questions that I think also will be useful for me for inspiration in this chapter. So in terms of the second part, so rather than jumping directly to climate change impacts and adaptation, what I wanted to do is to have a short subsection actually, that would cover some basic concepts and data issues. I think that just talking to people or as a reviewer, I see sometimes some confusions, and I think it's good to start with the same common descriptions about things. So the first subsection is on the weather versus climate. So sometimes we talk about impacts of climate change, and what we're doing is analyzing weather shocks, and so we have to just clarify things in terms of what we mean exactly by weather and climate. And so a simple way that I try to convey this is to think about weather as a random variable and climate as the moments, quantities describing the moments of these random variable, right? And then what does that mean for climate change, right? So we're changing the moments of a distribution. So that will eventually be reflected in the distribution, sort of the sequence of weather draws over time. Just wanted to make that clarification. There's some other terms like climate variability that I go into trying to define these terms. The second subsection is on data, on weather data. I think it's such an important sort of ingredient to all of these studies, many of these studies, and I just wanted to cover kind of the basics of someone coming in and then trying to understand what kind of data is appropriate or what kind of data is being used, and so I start from a very a broad kind of view of talking about instrumental, so things measured with instruments like thermometers and proxy data. So there's studies that look at, say, like paleoclimate, like very old, going back several centuries. So there are records for temperature data like that. So I just wanted to make touch on that point. Also in terms of the format, some weather data comes in as stations, and these are point data sets. And there's also, especially for the global studies or large scale studies, you see people relying on these gridded data sets that are either based on interpolation or reanalysis. So so I wanted to make that distinction. There's also this difference between atmospheric data, right? So temperature, precipitation, wind speed, and things like that, and land surface data, things like soil moisture, and also the role of like indicators like drought indices that use weather, that use atmospheric variables to try to get a proxy of land surface indicators. So I spent a little bit of time there. And one empirical thing that one practice that every researcher has to at some point do is that all of these data sets sometimes come at very different resolution than the economic data. And so the researcher has to come up with a way to aggregate data generally up so that the weather data is representative of a county or a state. And so There's various ways of trying to do that. One of them is trying to say, when you're dealing with gridded data, to aggregate things based on land cover data. So that's the top right corner is one example of how you can use those land cover data sets based on remote sensing to aggregate weather data using those as weights, so that you don't aggregate things in places where there's, say, no agriculture. Right, and I talk a little bit about this. Time is flying. I have to go faster than this. There's also the point about binning, and I show there that I think it's important. There's more studies using binning approaches instead of just using directly temperature variables. So I'll talk about that. And then unresolved issues regarding data issues, right? Measurement error, the importance of these weights, aggregation bias. There's a bunch of things that we still don't really know. And then you tend to see people doing things a little bit ad hoc in studies. The third point in this section is talking about climate models and what they are, and a little bit of the jargon surrounding this. I'm just talking to people who are coming into this field that they're confused. What is CMIP? What is CMIC-6? What are the latest models? And I just wanted to kind of highlight a lot of the terminology and what the climate experiments are, and all these RCP scenarios and what do they mean. So there's a little bit of that I cover here. So now let's move to more substantial chapter, which is on impacts. There's a bunch of sections here that I could potentially sort of concentrate a little bit or not. So I start with the role of adaptation, and I start with the definition of the APCC. And then I bring it a little bit more home and think about adaptation and frame adaptation as an adjustment, right? Adjustment from farmers in some input in response to changes in the distribution of weather inputs, right? And I make the distinction between short run versus long run adaptation. So where you have all inputs are variable and some inputs are not. Or where some inputs are variable and then when they're all variable, and then thinking about whether short run adjustments are intrinsically more pessimistic than long run input adjustments. And generally we tend to think about it that way because all the inputs are variable in the long run. But when there things like irrigation from, say, a dwindling water resource, maybe there's some adjustments in the short run that wouldn't be available in the long run. So I think that there's a nuance that's also important to think about, right? That it's not always that the short run effects tend to be more negative or more more pessimistic than the long run effects. Although the cases are a bit narrow. I wanted to, rather than just move to kind of the frontier studies or recent studies, let's put it that way, then I wanted to focus a little bit on kind of the history and how it all got started with biophysical models and crop models and people trying to, in the late 80s and 90s, trying to connect economic models with biophysical crop models. I think this is important to highlight how things got started. And because by understanding how things got started, then you see what are the criticisms that emerged and motivated new studies in response to these shortfalls. One of these criticisms was in early models, you had to really assume exactly how farmers were behaving. And so there's this whole discussion about the dumb farmer assumption and things with, with funky assumption names. And so that motivated the emergence of what is now called the Ricarding approach. But before getting there, rather than just talking about the history, I wanted to also talk about like the current status of a lot of these models. Whether it's like a IFPRI's impact model or a movement in the crop science literature comparing different crop models in the AgMIP, although there's economists there as well, but just to try to give a framework of what things that are happening and how the issues in that literature kind of motivating the emergence of the Ricarding approach that Mendelssohn and colleagues introduced in 1994, which is really a response to this inability to capture all the farmer adaptations that in a study. And so the idea here was to to account for adaptation implicitly by assuming that farmers are already adapted to their local climate, right? So that if climate changes, then farmers would autonomously change to these different practices. And the key point is that you rely on this cross-sectional variation in climate. Obviously, this is very vulnerable, and I go over the criticisms that were leveled at this approach: irrigation, issues with irrigation, issues with non-farm pressures and land use change. There's some improvements that people have introduced over time in terms of like making it more forward-looking, but there's also, you know, lingering issues that are difficult to get away from. Like just it's a cross-sectional approach, and so it's anything that is correlated with climate that also explain land values will affect your results if you don't control for it. So there's some approaches, and I talk about this in the paper, that are trying to control for omitted variables in a cross-section in funky ways. Okay, so there's a couple of studies in that front, but that's pretty much what I get into. Then I move into these panel approaches. I think the most emblematic paper there is the Shannon Greenstone paper in the AER in 2007. And I think the idea here is that rather than relying on climate, you rely on weather, and then you get these weather fluctuations affecting. In this study, in the first implementation was like profit, which is really net revenue, sales minus cost in a given year, using the census data from in the U.S. Context. And I think it was really, when you read that paper, it's really about trying to address these time invariant omitted variables that you can control with locational dummies. So it was a response there to previous issues. Again, this theme of responding to shortcomings of previous studies is kind of one motivating force, and it has been sort of an empirical, you know, more methods-oriented innovations that have been introduced, and one shortcoming here, one limitation is that a lot of these adjustments are only short run, right? So it's weather shocks. It doesn't really tell you much about the long run, right? So what if farmers were able to change what they're growing, right? So those are things that are not really captured there. So there's limitations again on this because the way that folks have implemented this, you know, you don't account for changes in inventory or big expenses and things like that, or the introduction of, say, regional or state fixed effects to control for regional price shocks. You introduce these dummies and then they wipe out kind of all the variation. So you're left with the only within state year variation, which might not be much there. There's also the fact that getting good data on sales and cost is very difficult, right? So the census has information on this, but it's every 5 years. So you might think that you're covering a long time period, but you might get like 4 time periods, which is not a lot. So you better get big a lot of action in those years. You better get lucky. So there's new studies based on AgTFP that resolve some of these issues. I have a paper also on that. But there's these effects are all still short run effects and no long run. And now that I'm presenting this, I think there should be more discussion on, and I do talk about it in the next slide, about thinking more about crop choice and land use change in the models, right? So where we try to model that adaptation more explicitly, at least the main channels through which we think adaptation might occur. This autonomous adaptation in terms of directly thinking about production. There's also this section on statistical crop yield models. I think there's been a lot of work, perhaps too much work on this. It's a low-hanging fruit. There's so many crop yield studies. It's not only economists, right? There's a whole field in agricultural methodology that works on this. And there's a very long history of studies doing this type of work. The most perhaps emblematic among economists is the Schlenker and Roberts paper in PNAS, which I feel is also a reaction to the fact that that 2007 paper in the AER didn't really find much action, and this was a way to dive into different channels and show, yeah, there's very large short run effects on yields, and there's a zillion studies now, including some of my own on things like this. And so my goal here is to connect this to a broader literature and try to understand the roots of this. So that's kind of the goal. I might include, rather than having it in a separate section, there's a section on crop yield forecasting that is not really about climate change, but has sort of, is related to this statistical crop yield model. So I might include a short parenthesis here, and also include a new subsection, so on crop choice and land use change, which I, in the first draft, didn't include something on this, and I think it's important. There's this recent approach that people are trying to use, like called the long difference approach, where rather than trying to see whether, rather than assuming that farmers are already adapted, you're trying to maybe determine or figure out whether farmers are actually adapting. And the idea is that you look at recent trends in climate, right? So you need a long time series, and you're trying to see whether there's a change in the sensitivity of, say, an agricultural outcome to these weather shocks over time, right? So you're trying to see whether there's a you know, where these changes go hand in hand, right? Whether you see some evidence that farmers are actually adjusting to what they're seeing. And there's issues with that, right? There's issues with endogenous trends where in the Midwest, it has warmed more slowly than the surroundings because there's large scale phenomena happening where you have a lot of evapotranspiration. It has cooled the local climate relative to the surroundings. So there's trends are actually endogenous in some of the in highly agricultural areas. But there's also issue with measurement errors in the within dimension when you're trying to tease out trends, and inputs are omitted. So I'll try to also highlight some of the shortcomings of these approaches. There's also studies that kind of want both things, like try to focus on weather and climate at the same time. So there's several recent examples, one more Nobel looking at European agriculture, and more recent ones by Merrill and Gemans, and Richard Toll just presented a paper recently on that. Antonio Bento and colleagues also has one, and Derek Lemoine also has a paper on this. So there's a lot of papers trying to come up with a unified way of trying to measure the adaptation. Not always apply to agriculture, but agriculture is generally kind of the case study. There's a few sections on that, you know, it would be crazy, I think, not to include something or just talk about irrigation. I didn't know exactly how to bring it in. So my idea was that rather than to have just a section about irrigation, would be irrigation studies that would shed light on climate change adaptation in some way. So that's kind of the idea here, and I'm still very at early stages here. Then the role of trade, I think, is very important. So Tom Hertel has done a lot of work on this with GTAP. There's also recent papers, you know, like the Costino and Donaldson paper, and I'm sure I'm missing a bunch. So that's kind of what I wanted to get, is like the role of trade in sort of modulating these impacts and sort of the transmission of these impacts. So there's a section on trade, and then one section on attribution of climate change impacts. So that, you know, that Mendelssohn paper that I showed at the beginning, that chapter, was an attribution, was trying to show whether past climate change has affected agriculture. I think a lot of the emphasis is on the future, but we know relatively less about things that have happened. So there's studies that are trying to look at trying to tease out the effect of recent climate trends. That's one way to do it, and also using counterfactual climate scenarios, which is a more recent technique, and there's a couple of studies on that front as well. The last subsection of this climate change impacts part is on things that I think are missing, right? So there's so much work done on cereals and certain regions of the world, and there's a lot to actually to look at. Tree crops, livestock. There's relatively less work on these other commodities, Quantifying the adaptation cost, the adjustment cost to a different climate. We tend to just look at the short run or the end point without really getting a picture of what's happening in the middle, right? That picture in the middle. I think I ran out of time, but let me just try to finish here. The role of farm policies in general, whether they're crop insurance subsidies or support policies, how are those interacting with what farmers do, and how is that making agriculture more or less resilient to climate? The role of R&D, so a lot of the focus has been on just production, right, and not enough on either on the sort of downstream or upstream of that. And so I see the R&D as, given that it takes decades for these investments to have a return, is what is the historical role of R&D in making agriculture more or less resilient to climate, and what could be the future role? Other things that have been relatively unexplored is the impact on things like farm labor. There's a lot of work on labor in other sectors of the economy, but not really much on farm labor. Talking about downstream things, the nutrition and not just quantity, thinking more about the quality of production and post-harvest impacts as well. And another point that I wanted to mention is pest pressures and changing these are obviously difficult things to cover. So very briefly on climate change mitigation, is a very thin section, and I'm way behind on this. And what I would like to do is to really focus on what are the main research questions and methods used in this literature. To me, from what I got, from what I could gather, is that a central question is how much mitigation would we get from ag if we had some price on greenhouse gases, right? If we had a way to price in, like, how much would we get? So in a way, it's like trying to recover kind of the supply curve, mitigation supply curve from the ag sector. So that's really kind of one of the main questions, but I'm also curious to see what other thoughts you have regarding this. So I won't talk about this section, which I might just make a little parentheses under the climate change impacts part. And that's what I have. So couple questions that I have for you. I want to know whether you think the audience is right, whether I'm kind of, have the right scope here also. Then whether you see key gaps. Should I talk about things like crop insurance? And if so, how should I talk about it here? Also, as I was talking about, particularly in section 2, I was like, well, what if I included some code here? Would that be useful, particularly for new researchers? Like if there's some code attached with the chapter where you can manipulate weather data, would that be something that would add value to the chapter? And how to create bins and things like that. Yeah, is there something that you would like to know more about that I'm not even talking about? So that's what some of the questions that I have for you. So thank you for your time. Thanks.
Great, outstanding. Thank you very much, Ariel. By the way, this is Chris Barrett. Let me just briefly introduce myself along with David Just. I'm one of the 2 editors of the handbook. And let me apologize. There's apparently a cross up here. So let's finish up this session. The whole thing's supposed to be timed for Central Time. So thank you, Ariel, for pinging me on email, because that's why I wasn't there. And that's why we have right now 45 participants when we were maxed out at 100. I'm afraid that part of your audience is going to be showing up in about 35 minutes. But if Tom's okay with it, why don't we just continue this discussion, and when we get to the end of the hour in the discussion, I can fill you in on the adjustments. So I think, Ariel, if you can stop sharing your screen, then Tom can go ahead. So Tom Hertel at Purdue University is Ariel's discussant. Thank you very much for joining us today, Tom. I trust you recognize Warren Hall in the background.
Yep. Thanks, Chris. Thanks, Ariel, for a very nice presentation. Everything coming through loud and clear. You see in my slides, Chris? Full screen?
Yep, we see it great. Thank you, Tom.
Okay. Nice presentation, Ariel. I like your vision for this chapter. I've just highlighted here on this next slide the things that were complete that I could read. So I was taking notes as you were presenting. factoring in your vision for some of these non-highlighted sections, which I think are important as well. So the chapter is probably about 1/3 done. There's some great stuff there. I'm mostly going to be commenting on the other stuff. So responding in some sense to your questions at the end, Ariel. I really like the basic concepts and data section, and let me underscore, yeah, I love the idea of including code. So this may be the most useful part of your chapter, the bit with the longest shelf life and the most valuable to your target audience. So I think that I would not limit the basic concepts and data section, including code. It's a great idea. And while you didn't have a chance to talk much about it here, you have developed nicely the work that's culminated in your recent papers, panel estimation of impacts of climate on TFP, total factor productivity. So I think that's really appealing. It's covering the full ag sector as opposed to just a few commodities. It focuses on something that's a key driver of long-run U.S. ag output. Just to underscore that, here's a slide taken from Keith Fugly and colleagues at ERS USDA. You can see that essentially growth in U.S. ag output since World War II has been largely due to TFP. So how climate affects TFP, in this case, Ariel's looking at the short-run level effects. Is TFP a little lower because of this, these climate impacts? That's important. But what's really important, and I think Ariel was anticipating this in some of his some of the slides, it's not yet in the text, but the fact that where does this TFP come from? It comes from R&D spending. So Keith Fugly's work and others shows that this large productivity growth in U.S. agriculture can largely be explained by historical investments in R&D, public R&D. The private sector tends to capture most of the benefits of that R&D through higher prices. That doesn't show up in farm level TFP, but public R&D can explain most of the productivity growth, and how that will change in the future under climate change is a very interesting question. So will knowledge capital that's been accumulated through these investments, this time frame is about 50 years, based on data from the 20th century, maturity peaks about 22 years. Will obsolescence of knowledge capital be accelerated as we move into a new climate? And then will the translation of that knowledge capital into productivity growth be affected by climate change? So those that's really interesting questions, get you into a new set of data, new set of limitations, because building this long time series on public R&D is difficult. So I like as I said, I like the panel estimation with TFP as the dependent variable, but that's typically done at the national level, or in the US, we happen to have a time series that ends maybe 15 years ago, TFP by state, but it's hard to get your hands on that. It's important to complement the TFP work with other studies. And I think it's really important. One thing, Ariel, I'd like to highlight, I think is, you've hinted at it in a few places, but I think it's going to be really important to build bridges to the biophysical studies. If you look at who is really informing the IPCC, where does the IPCC turn when they're trying to assess climate impacts? And largely they're turning to these crop these crop growth model studies. So here is just a very recent paper from the Global Gridded Crop Modeling Intercomparison Project. So you can see they're following CMIP very closely in their protocols, in their approach. This particular group has a place on the web where anyone can contribute their model, check it against other models, validate it historically, compare the future. So this is important work that's being undertaken. It's not getting into the economics, but we need to bridge to that, when we need to leverage that knowledge in our future studies. An example of this, bringing these more closely together, in this case, the agronomic growth models and the statistical models. So in the last IPCC round, the agronomic growth models really dominated the submissions. statistical yield models, I don't know, maybe 10 or 15% of the submissions of estimated climate impacts. There was a special issue of Environmental Research Letters published a couple of years ago that showed an important finding. So these, leave the economists aside for a moment. There was a big fight between these two groups, arguing, who was right, these different estimates. But this paper showed, and I'm just showing you one particular figure from that when the work is done well, we're talking about the same location, the same kind of measurements, they generate very similar estimates. So this is promising if you're wanting to bridge first agronomic growth models to statistical yield models, then statistical yield models to the econometric models, say, that Ariel was talking about. I think there is scope for bridging. We need to think more about that. There's a very interesting paper that David Lobel published a number of years ago. He was getting all these IPCC submissions and started looking at them. And one of the metrics was there adaptation or no adaptation factored into these, as I say, largely agronomic models? And he had this hypothesis that's in this global food security paper, adaptation illusion. He was looking at these and lining them up and thinking, most of this, what they call adaptation, is simply assume something good happens, that something is done better, that you apply more fertilizer in Africa. Of course, it boosts yields in the future, but under future climate, but it boosts yields under current climate as well. And then, so in that special issue I alluded to, Fran Moore led a paper where we tested this hypothesis, and we found out, indeed, that the dominant factor in these studies is the adaptation illusion. Essentially, when they're talking about adaptation, they're talking about a simple shift, upward shift in the yield function, very little action off the interaction with temperature. So this is something to bring to bear on this. I think that hasn't been widely enough appreciated. And this just generalizes to a whole host of economic questions that I think need to be straightened out. And this closer bridging with the AgMIP community, with the crop modelers, I think will be important to correct some of these illusions. Another area where I think bridging is necessary has to do with the treatment of these yield estimates in a lot of studies. So in economic studies, if you take the economic group from AgMIP, a smaller group, but nonetheless influential, their studies under the last IPCC AR5 took these yield estimates that have been undertaken and incorporated them in an economic model as a partial factor productivity change. So it influences the productivity of land in agriculture. Of course, many of those economic models they were using just had yield times area as total production, but those had production functions. These were treated as a factor disaugmenting technical change on land. That contrasts with Ariel's work on total factor productivity, arguing that climate change affects the productivity of all inputs. This is a hypothesis that needs to be tested, I think. So I would urge Ariel and others to look at this more closely. I mean, if you just look at it out of that food policy paper Ariel alluded to, there's some examples just showing how big the difference is depending on whether you interpret this driver of ag output on the left-hand side as the TFP change, which is the A term here. These are all percent changes, or the bias technical change, the A sub I. It's big difference in output, big difference in price impacts. Labor, really important, and I'm glad Ariel raised this. It's going to be very important to address this in the future. Work done by colleagues here at Purdue has and incorporated into some of the climate models now, the community land model. It shows that this heat stress generated by people working outdoors in agriculture, it becomes very hard to dissipate that under high temperature and humidity. And this is particularly severe, obviously, in the tropics, where temperature is already high, humidity is high, and that can create big challenges. So this slide just contrasts 20th century climate on the left under two protocols, for evaluating the labor impacts, and plus 3 degrees C warming. Big impacts on labor capacity in the tropics, big impacts on the demand for labor in agriculture. If people can't work as many hours, have to take a break every hour, you're going to need more workers to produce the food that's being demanded in this new equilibrium at higher food prices. But it's not just the demand side for labor, it's the supply side as well. So diminished labor capacity, as I've been talking about, is a form of labor disaugmenting technical change. Go back to that production function. It's the AI related to land, to labor, but there's also impact on labor supply. And Sol Sang just presented something that's, it's based on this huge amount of work that's been done. Greenstone's leading the work at Chicago, Sol Sang at Berkeley, but they've combined efforts to assemble data from across the world on labor supply, and they've looked at how high temperatures generate disutility and lead to workers choosing to work fewer hours. So there's a demand side, but there's also a supply side, and one has to factor both of those in to get the full picture, both on equilibrium labor employed as well as wages and food prices. Just to wrap things up, gee, there's an awful lot to cover just to do climate impacts right. The mitigation literature is huge and growing. I reference here an AEPP special anniversary issue on research needs and climate change. You might take a quick look at that. But I think doing a better job on climate impacts is the way to go with this review, a more comprehensive job. You've done a great job on what you've done. You've got to extend that and probe some of these new areas. I think the crop forecasting, again, that's a citation perhaps to some related work, but a check section on that, I think is gonna, it could take you down a rabbit hole in terms of other forecasting work, it seems to me. And livestock, clearly under investigated. We need more on that. You note that. I just added these. I liked your idea of spending more effort on land use change, crop choice. I think that is under investigated. There's good contributions that could be made there. Attribution, yes. Just concluding on the general equilibrium and trade thing, I really want to underscore one point. The Costino, Donaldson, Smith piece in JPE, very widely cited, influential, finds that trade isn't important in adaptation to climate change, and I just don't believe it. And I refer you to the NBER paper by Guel and Laborde. I was at that conference when these were presented. I think it has to do with their assumptions on consumer demand for food. If you can cut per capita consumer demand for food by 40% in sub-Saharan Africa, as they do in some of their scenarios, of course you can adapt without trading, but that's not realistic. So the parameterization of that model is not, I think, not right. Spatial correlation is going to be really important for trade, and I just highlight the Dingle, Sang, and Meng paper on that. So I'm stopping there, Chris.
Thank you very much, Tom. That's a fantastic set of comments. Ariel, you've got a lot to digest there. I really like what you're doing with this, Ariel, and I appreciate Tom's comments. My only suggestion beyond the points Tom made was there doesn't seem to right now be much attention in your draft outline or the content you've got in place to extreme events and the changing risk profile of agricultural production, but potentially also of trade and marketing. Issues of flooding and port infrastructure and roads and so forth are obviously going to become more prominent in the future, we expect. So you might think about what is there to cover that relates to the changing risk profile of agricultural production and marketing with climate change. I think that's a very short section because I don't think there's much out there, but it may be worth flagging. We have time for questions and comments from others. We ask that you use the raise hand feature, please, if you would like to make a comment, make some suggestions to Ariel, or if you have a question for Ariel or for Tom. If you, for whatever reason, do not wish to speak, but you do have a comment or question, feel free to pop something in the chat box. This is being recorded, so keep in mind that whatever is in the chat box is getting captured as well.
Chris, I'm sorry to not raise my hand, but I cannot find a raised hand feature on my screen.
Please
I
go ahead.
I also don't have a question at the moment. I just thought I'd point that out. You might need to instruct us.
So if you go to the participant, if you click on participants, you should find a listing of all participants, and on the lower right side on my screen, probably on yours, it gives you a raise hand option. Is that correct? Do you see that? Yeah, Lyndon, please go ahead.
I'm so sorry to be confusing. That's not Lyndon, it's Leah. The real Lyndon is also on, and I was just testing to make sure it works. Hi, Ariel, that was great.
Okay.
Thank you.
Names are all mixed up. I don't know what's going on.
Yeah, that's
There's 2 Chris Barretts here.
that's odd. Yeah, that sounded like Stephen Swallow who spoke up, but my name came up, so I'm not quite sure what that is. All right. Ariel, do you perhaps have any thoughts, any reactions to some of the feedback you got from Tom?
Yeah, I wholeheartedly embrace all the comments. I do think that given where I am now, I'm like about 7,000 words now out of 30,000, and there's still a lot to cover on the impact side. So the mitigation part, I'm increasingly inclined to do a better job just on the impacts and adaptation part, rather than also try to do things on mitigation. I think it would do a disservice maybe at the chapter and affect its shelf life. So I'm inclined to drop that part and just focus directly on impacts and adaptation. And all the comments are extremely well taken, Tom. I think they're great. So.
So Will Masters has a comment in the chat box. Will, I don't know if you want to speak up and share your observation.
It's a very minor point, really, in the scheme of things, but there is this very interesting literature on how increasing carbon levels in the atmosphere and also heat and moisture alter, so familiar thoughts about how much protein and how much micronutrients and those may become obsolete, right, in the face of heat stress.
Yeah, that's a great point. And I recently had a meeting where these topics were being covered, and I am familiar with a few studies, like looked at rice and wheat, and quality there. There's a couple in AJE for rice, I know, but I could certainly include a chapter, a subsection on quality impacts directly. And try to address. I know there's a lot of gaps there, but at least like showing what's already done, rather than just leave it as unsettled issues. Perhaps like give some coverage on things that have been done, and point out to where the gaps are. Right. So there's very little. Generally, like the quality data is not as easy to come by than the quantity. So that obviously is one issue. If we had all the data, right, we would be doing this. But there, so yeah, so the CO2 thing, and then that's something that we can mostly do in experimental settings, right? So the observational part on this, it's very difficult. So that might be one of the reasons also it's not appealing to empirical economists in general, just because of that. But that's something that is very important to point out.
Ariel, another thing that I've been hearing a lot from plant breeders and agronomists recently is their concern over the changing ranges of pathogens and pests and what that means to adaptation. This relates closely to your points about changing TFP growth rates, because this is impacting the suitability of technologies that are already underway. I mean, as Tom was referring to, there's a long lag between when the bench science starts and when improved germplasm is out in farmers' fields. But I'm hearing a lot of concerns from agronomists and breeders in particular, that they're just starting to see pests in places that they didn't see them, and they need to adapt the crops to these. And until they and that, I gather there's just not a lot that the entomology community has done yet, or the plant pathology community has done yet, to provide reasonably good predictive tools on what pathogens and what insects one needs to be prepared for 20 years from now in different places. I don't know if either you or Tom have thoughts on that. Is that a major issue? I'm not aware of there being much yet in the economics literature on this.
I haven't seen anything really on this from economists. And you know, I've heard so many discussions. I have a bullet point on that, like on changing, you know, on the impacts on diversity and pest populations. Generally, like data on pests is difficult to come by. So again, going back to the fact that we think we need absolutely need observational data to do something might be kind of holding us back to get active in certain areas of research. So maybe we need to be a little bit more adventurous.
Chris, you pushed me on this in the food policy piece when you were. So there are some references in there. Yeah, I'll take a look at that to both, you know, sort of the economic literature. The ecologists have been worried about this, and they are documenting cases of pests moving northward. I mean, in principle, pests and weeds are very adaptable. A lot of the crops that we're eating are not. So they tend to get outcompeted in these new environments. The pests evolve very quickly. So it's a big challenge.
Annemie, you have, I think it's Annemie.
Yes, that's right. I'm on the under the correct name. Thank you, Ariel, for your wonderful presentation with your excellent overview. I'm not very familiar with the topic, but one thing I was wondering about is that you mentioned the effect on cereals, you mentioned the effect on livestock, the effect on these different components. And I'm just wondering, how much do we know about the effect on entire livelihood or cropping system? If one goes up, the other goes down. One might be affected by certain extreme events, like Chris is saying, the other is not. How do we, I don't know how much we know about this, but these complex livelihood and complex cropping systems of a lot of farmers in developing countries, if we, do we have much on that in terms of, you know, the big picture still on the production effects, but when the production consists of many different components?
I've seen there's a literature on like crop diversity and resilience, and you know, at the farm level. So having that, and even within fields, right? So I know there are studies, and it tends to be not necessarily economists, but more like, I would say, agricultural ecologists working in this space. So there is something there. There's literature on this, and I'm glad that you brought this up, so that I can really think about how to bring it in, because everything has been, you know, as if you know, we have these impacts on, you know, one commodity, but you know, when we look at the overall, you know, types of agricultural systems, they don't look necessarily like they do in the U.S., right? With the very large swaths of simple rotations and things like that. So I think that deserves some attention. I have to think about exactly where to have, maybe when I talk about crop, you know, changing land use, you know, yeah, changing land use and crop switching, I can also talk about this. I don't know if it will deserve a separate subsection or in that same one. So that's a good point.
Thank you. That sounds great. Thank you, Ariel.
Chris, can I follow up on that?
Please.
I think another dimension of this, the broader impacts, is just the impact on price. So the early studies in the US of climate change said, oh, agriculture is going to benefit. This is a great form of supply control, which is the way the US used to operate in order to raise prices, just restrict supply and counting on the demand to be inelastic. So that obviously becomes more complicated with many commodities, a global integrated economy. But I think the price impacts are important. As we saw in the food price spikes in the early 2000s, there was actually poverty reduction because of, in many parts of the world, look at Derek Heddy's work, many parts of the world because of the benefits to livelihoods. So that's a different kind of a shock. That was a demand side shock, but it bears some discussion.
Would you include that, Tom, separately from trade in terms of the impacts?
No,
or
it fits nicely with trade.
Okay, because there's also, there's this, papers like Alston, Julian Alston had this paper in Science a few years back about prices in the long run, and how it's more about R&D and trying to increase productivity. So that's not really trade, but it focuses on prices, but in the long run.
I don't think any of that, you can look at any of that absent the trade dimension. If you're talking about climate change, it's not just happening in one region, it's happening around the world. So I think put it with trade is my view.
Yeah, I would echo that. We have a comment in the chat box from Takabor Raman. I don't know if Takabor, if you'd like to speak up, just proposes talking about aquaculture and fisheries economics. Takabor?
Yeah.
Please go ahead. We can hear you.
Yeah, I'm thinking that has a very great impact on the economic life of, especially in developing countries. However, perhaps this thing is missing in the proposed book chapter.
I totally agree that. Oh, yes, the sound is cutting a little bit, but it is that I've been focusing on land and and so yes, I agree that it is missing. It means that I need to do more homework on aquaculture and see whether there are studies that are directly climate related. I wonder if it's more related to the supply of water for aquaculture, systems, quality and quantity of water. That might be one angle to think about, or whether temperature affects these systems. I have to see whether there's a substantial literature there, and otherwise that I should definitely put in unresolved matters, because when you see the rise in aquaculture, especially in China, it's just exploding. So I think this is obviously a major type of activity.
Yeah, and often it is seen that the fish farming are taking the land of agriculture. So agriculture production is falling, especially in developing countries where the fish farming is rising. So there's a kind of reuse of the land, and sometimes it is difficult to come back from the fish farming to the agriculture farming. So, and there are increasing use of the pathogen and pesticides and different medicine in aquaculture that have a great impact on the environment and on the society, and even in the food chain of the country.
Great, thanks. Yeah, Ariel, I know Roz Naylor at Stanford and Chris Golden at Harvard have both written on climate change and fisheries and their impact on nutrition, including some of their spillovers into aquaculture. A great deal of fish food for aquaculture is actually small marine harvests, which are impacted by climate change and coral reef systems, et cetera. So there's a small literature on this, but it's probably worth including a couple of paragraphs flagging that this is a significant issue. But I don't think there's been a great deal of work by economists on this, other than Roz, I can't think of a whole lot of people who've been working on this. But those who know of that literature, please send something along.
Very useful.
So I don't know if this is Lyndon or perhaps Leah, but one of you has a comment in the chat box. Would you like to share your observation?
Sorry, that's Leah. I only thought that that was a good comment, and I've anecdotally, and I know I've read about it, but I don't know if it was in economics literature or more Aggie literature. I've read about aquaculture being used in sub-Saharan Africa really as like a coping mechanism for changing agricultural systems. And I recently was also reading about aquaculture historically in the US, and the sort of importance of credit and startup capital and the way that credit was denied Black farmers in the United States for aquaculture, and how that sort of was a harbinger of increased inequality over time within U.S. agriculture. So I think aquaculture often is like there's a big startup cost, right? So if it is being used as a coping mechanism, heterogeneity in availability of the stuff to start up that coping mechanism would be sort of interesting. Anyway, that's a bit of a side issue. I just thought it was an interesting idea that he pointed out.
Thanks. Ariel, do you have any closing thoughts, comments?
Well, not really. Just saying thank you for the opportunity to write this chapter. I'm excited about it, and I hope it's going to be useful for hopefully a decade.
Yeah, we hope so. We hope so. So thank you very much, Ariel, and thank you, Tom, and participants. Some very good comments and questions. Let me just provide a really quick backdrop here. David, Justin, and I are the editors of volumes 5 and 6 for the Handbook of Agricultural Economics for Elsevier. I'll come back and explain a little bit more of it in an hour when I think we're probably going to get retimed correctly. But the basic idea of this workshop was to open up the opportunity for people to provide feedback to handbook authors while they're still in the midst of writing. So what you're hearing are works in progress. Some are relatively complete drafts, most are still quite incomplete drafts. But we wanted to give the community a chance to both hear the thinking of the handbook authors, as well as to help to shape some of the contours of those chapters. The volume 5 chapter drafts are due February 1st. So as most of you have figured out, perhaps especially those of you who are just joining in the last few minutes, the email invitation you were sent was mistakenly set for Eastern time when the program is actually set for Central time. Because we are concerned that there will be people joining an hour later based off of the proper program, we're going to pause the program now for an hour so that we can get it synced up correctly with the original published program. So the chapter by Leah, Palm-Forster, Leah and Kent, Kent I see online already. Thank you for joining us. We'll present that at its originally scheduled time of 10 Central and 11 Eastern rather than at 10 Eastern where we are right now, because I'm afraid we are going to miss people who have taken the online program into account properly. So my apologies for that. If you want to see the online program, I put it into the chat, and I am sharing it now. You can see it here, I hope and expect. So you can see we have supposedly just finished the 9 to 10 Central window, although it ran 9 to 10 Eastern inadvertently. So apologies to any of you who missed a terrific conversation, presentation by Ariel, comments by Tom, and by several others. So why don't we take a break, and we'll reconvene in about 45 minutes. I can offer a few preparatory remarks, and then we can jump right back into the program as originally scheduled, with Kent presenting on behalf of him and Leah. Okay. Thank you very much, everybody. We'll rejoin in about 45 minutes at 8:40. No, at 9:45 on Central Time. Okay. All right. I'll leave this program up so that people can see it if they wish. Thanks very much. Great job, Tom. Great job, Ariel. Take care. See you all in an hour.
Yep, I'm here.
I've made you a co-host. I don't know if you want to share slides. I'll make a couple of brief announcements before we get started.
Okay, great. Chris, can you just confirm that what?
Yep. See them just fine.
Great.
And Stephen, do we have you back now? All right. For those who have just joined us, my name is Chris Barrett, along with David Just. I'm one of the two editors of the upcoming Handbook of Agricultural Economics, Volume 5 and then Volume 6. Today and Thursday, we have a virtual workshop hosted by the Agricultural and Applied Economics Association, the AAEA, on Volume 5. For those who were hoping to catch Ariel Ortiz-Bobea's presentation of his chapter on climate and agriculture, I apologize. The original settings for the Zoom meeting started an hour earlier than programmed. It seems that those got crossed up between Eastern and Central Time. So Ariel and Tom Hertel, his discussant, went ahead and presented, but an hour earlier than originally scheduled. So if you were tuning in hoping to catch that, my sincere apologies. The recording will be available in another couple of days through the AAEA. So we are recording these sessions. They will be available afterwards. So please keep that in mind as you participate. Keep in mind that anything you send in the chat, including private messages to individuals, gets captured in the recordings. We ask that everybody stay on mute unless you are speaking. I or David, whichever of us is moderating a session, will invite you to unmute and ask a question or raise a comment. We ask that everybody hold questions for the first 10 minutes just to give the presenter a time to make it through a good portion of the content. And we ask that you use the raise hand feature to signal that you would like to make an intervention, to raise a question or make a comment. If you're unfamiliar with how to find the raise hand function, if you go to the participants listing on the bottom bar of your Zoom toolbar, if you click on that, you should see a raise hand option beneath the listing of names. And if you will just indicate that, then I will know to look for you and I'll call on you. Once you've asked your question or comment, or if you decide you no longer wish to ask a question or comment, please be sure to lower your hand. Before we get started with Kent's presentation of his work with Leah Palm-Forster, let me just briefly thank the AAA, especially Allison and Kristen and Mary and Jessica, who've handled all the details of organizing everything. Let me also thank Elsevier, which publishes the handbook, Jason Mitchell, the editor, and Shelley Bryant, his editorial assistant, have done a great work in helping organize everything. Especially thank the authors and discussants. For those of you who are unfamiliar with the handbooks, these are the reference series Elsevier publishes roughly once every decade in each subfield in economics. So the volumes 1 and volumes 2 of the Handbook of Agricultural Economics were edited by Bruce Gardner and Gordon Rauser and published in 2001 and 2002 respectively. Then volumes 3 and 4 came with a lag of roughly a decade, edited by Bob Evanson and Prabhu Pingali. And now, roughly 20 years after the original first 2 volumes, we are preparing volumes 5 and 6. So the purpose of the workshop today and on Thursday is to give the authors of the volume 5 chapters a chance to present to the community the basic ideas, the outlines of the frontiers that they wish to cover. So the handbook mandate is to provide a self-contained description of the research frontier and upcoming issues worth investigating. It's really meant as a compendium for advanced graduate students and for faculty entering a new area of research so that they can quickly have a guide to what are the current thinking around theory and methods and data and empirical evidence, and it provides a guide to kind of some of the key topics for future research. So we're really fortunate to have an extraordinary group of authors joining us for this volume 5. We had a nice kickoff from Ariel Ortiz-Bobea from Cornell earlier today for the first of the chapters on climate and agriculture. And now we'll hear from Kent Messer presenting his work with Leah Palm-Forster on experimental and behavioral economics to inform agro-environmental programs and policies. A discussant after about 25 minutes will be Stephen Swallow from the University of Connecticut. So let me turn it over to you, Kent. Thanks so much for joining us today.
Well, thanks, Chris. I just want to confirm that everyone can hear me and see the slides.
We see the slides fine, thanks.
That's great, thanks. Didn't want to have a 25-minute discussion with myself, so I'm happy to be here. And thanks, Chris, for this introduction and all your work in putting on the handbook and putting it all together and hosting this AAEA workshop. I appreciate your work and David's work in pulling this together. It's a great service to our profession and a lot of effort I know that you're undertaking. And so also thanks, Stephen. I'm looking forward to your comments and insights to this later today. So I'm happy to present our talk today. Leah may be joining us, may not be. She has just delivered a beautiful baby boy about a month ago, and so is on maternity leave. So I'm happy to talk about our work and our thoughts as we move forward on this chapter. As a general introduction to people who maybe aren't so familiar with the agro-environmental programs within the United States, we're talking about programs that spend roughly $6 billion every year on a variety of different alphabet programs, but the Conservation Reserve Program and Stewardship Program and other things that all fall under this category. And one of the questions is, to what degree could behavioral economics or experimental economics help inform programs like this? And of course, if this is just our federal level of expenditures, we see lots of things at a state level, local level, other countries, nonprofits, all entering this sector, trying to say, how can we, get joint benefits from agriculture that are not only the food and fiber, but environmental services as well. Things that come up in this type of discussion are various practices are very common to think about. What are farmers doing in terms of land use? How are they growing their crops? Are they putting things fallow or something? So here's a question of no-till practices, right? So this is a way of not having to disturb the soil on an annual basis. And we can see that this has been a program that the federal programs have been supporting at various levels for a number of years now. And if we look at a map like this around the United States of where's no-till happening or not happening, there's interesting things that pop out. And here's one that maybe pops out to me because I'm from South Dakota originally. And you look here and you go, well, isn't that weird? Why is it that South Dakota has essentially no-till, no-till happening in it, while its neighboring states of North Dakota, Minnesota, Iowa, even Nebraska seem to have, fairly large amounts there. And so, these are questions that, are worth exploring in the context of developed countries. Why is it that this is happening? Is there issues of adoption? Is there certain programs that aren't being rolled out there so that they don't have the technical assistance? Is there a problem with the data that maybe is not capturing what's happening in South Dakota? These kinds of are interesting questions. And so, when we look at partnering with USDA and think about how do we inform evidence-based policy, which is supposed to be this new push, right, in the federal government as we move forward on the Evidence-Based Policy Making Act, having new evidence on why farmers do or do not adopt things, or how do they persist. These are the type of things that behavioral and experimental economics may be able to provide some insight into. So I just use it as an example to help illustrate where we're going with in terms of this chapter, because already when we thought about it, when Leah and I sat down and thought about it, I was like, well, there's already a lot of good work on experimental methods. That's been around for a long time, and it continues to be updated now and then, either just general games, or how do we relate to consumer behavior. So there's a lot of good stuff there, both summary articles as well on Chris, some of your work on RCTs. Do we really want to start from scratch there? That doesn't seem like a good spot. And likewise, behavioral economics has a lot of different insights that are there that have been captured in book form or journal articles and summary. And we really wanted to try to make sure that this chapter was somewhat distinct from that. And I think it was in line with what Chris was just talking about. One is it's supposed to be focused on, graduate students, new researchers in the field, and to really highlight the unique challenges that come with looking at agro-environmental contexts, right? So most of the behavioral economics work has been done on individual decision maker, utility maximizers, things like, are they going to be, what type of retirement program are they going to enter in? How does this affect their food choices? Where do we see things in terms of organ donation? These are the classic examples here. That might be utility maximizers. Here we're often talking about small businesses, profit maximizers in the developing countries, and how do we provide these impure public goods through their actions at the landscape level. And we've seen a lot of work in the developing countries, and Chris has been a big part of looking at experiments in developing countries, but there's been a lot less done in developed countries. And so we thought, well, let's focus our chapter there and help researchers understand the opportunities and the challenges that arise from this. And so that is kind of, given the applied nature of this work, we wanted to highlight a lot of methodological things while hitting that literature, so people know where are the gaps, where are the key elements that have been well explored in the literature, and go forward. And then we kind of recognize that even though we were trained as experimental economists in this area, that there's still some gaps. Some of that's just emerging important techniques that need to be emphasized. And so we wanted to kind of hit on that and make sure that the chapter is forward-looking and thinking about, what are the things like power analysis and pre-registration and things like that we weren't trained on as graduate students, but certainly the next generation needs to be and understand the pros and cons and opportunities that lie there. And so I'm going to talk about that. And we've written most of our chapter at this point, but we have lots of opportunities to make improvements. So we'll talk a little bit about the lessons for behavioral economics. We'll talk about what's been done experimentally in this area, and then talk about laying out kind of 4 stages, like how do we begin to inform agro-environmental policy with these approaches, and how do we think about that, and then end up with some recommendations. Now, I'm going to throw in a little light bulb. So, that's my get out of jail free. So if you don't like what I said, you can give me comments later on. You can in this discussion or later, and I'll kind of highlight some areas that I think both Leah and I would be particularly welcome for additional suggestions or ideas. So we'll throw that light bulb in a couple spots. From a behavioral economics perspective, and again, not knowing who the audience is today, I like to think about these as kind of models of human decision-making, where economists feel very comfortable with Dr. Spock-like decision-making, right? These are very rational people who can calculate high levels of probabilities and risks and make very logical decisions. And yet when we think about ourselves, we might find ourselves more like a Captain Kirk, right? The recognition of complex thinking, the value of thinking about logic and probabilities, but also some gut instinct, right? And sometimes just we're being a little bit driven by raw emotion. And these might be the differences in in a simple form between behavioral economics, which might be thinking of people more like Captain Kirk, a more complex model than a Mr. Spock would be. And then the question is, to what degree does this, relate to a farmer or a landowner, right? And again, we've got complex situations where in the developing world, you would have some, owner operators, but other times you have landowners and the operators are separate. Who's making those land use choices? How do you get them connected to agro-environmental programs in this context? So, that's a little bit of the challenge. And again, if we think about the fact that we haven't seen a lot of behavioral economics in this large scale, high stakes rural context, that may matter a bunch. Now, Dolan a while back wrote, kind of a simple way of looking at the different insights from behavioral economics, things like messengers and incentives and norms and defaults. Basically called it mind space, right? So each letter of mind space would matter, and we could look at it and understand a variety of different types of behavioral insights and how that could impact things. And again, Dolan was thinking primarily about individual decision making and utility maximization in this. When we went through and tried to look at how did these types of behavioral changes get related to agro-environmental contexts, Leah and I found that there was really a lot of absence in it. And there are certainly numbers of papers that have looked at things like norms and how do different social pressures impact things, or how do messengers impact behavior if it's coming from a USDA or if it's coming from an extension service person or from some type of peer, but even that's been really few papers there. And there's other areas that just haven't been dealt with at all, right? So, if we look at even the basic mind space, and I put the word plus in here because there's obviously some behavioral insights that aren't even part of that fall under those kind of mind space, but it's really a small literature out there, and a lot of them are lab experiments that have been done. Only a couple have really tried to scale up to the administrative data level, and I'll talk about that as being kind of our stage 4 recommendation. So when it thinks about where does behavioral economics fit with agro-environmental programs, there's a lot to be done here, and I think that's an opportunity, and it probably speaks to some of the challenges, right? So if it was really easy to do, these things would be probably already taken off, or we find as these aren't as relevant in the landowner decision making. So we might be running into some publication bias where it's just hard to publish the work out there because these things aren't having the large effects that we've seen in other contexts. So we'll take time in our chapter to outline this mind space plus world. Think about it in the context of, where would this matter? What kind of things could be explored? How can we look at things? We see in the real world examples where if you're a good steward of the land, you might have a sign put out by your farm saying, this is a water-friendly farm. These kind of things seem like they could be hitting on, issues around maybe commitment or ego, but they just haven't been tested in any way. And how do we do that in an effective way? So we'll talk about that behavioral economics side of things and hit on that. Then there's other more robust literature on using experiments to test various designs of agro-environmental mechanisms, right? And so, we might find that there's a nice theory. Kathy Sagerson works out a theory on non-point source pollution, for example. And we say, does this really work? We can't go out and, do this out in large scale watersheds to see if it works, because we're going to be taxing large farmers, or maybe we could do it, but it's not politically feasible at this moment. But, a lab is a good setting to test it, see, could it work in a lab setting? What types of insights can we learn from auctions and auction theory and procurement of environmental services and going forward. So, often these are situations where the knowledge is hidden from the regulator, right? So again, if we think about a non-point source pollution, we don't know where this pollution is coming from, but in an experiment, we could observe that, right? We could have a sense of the whole overall impact from society, the individual decisions. And so we've seen lots of different work that has come out on different agro-environmental schemes that are there. And so we'll hit those literatures. They're robust. Our ideal, I got a little light bulb here. How can we frame it in a really attractive way? It's still kind of we're kicking around with, like, how do we draw across these different environmental challenges and think about what the literature's hit on. We've got groundwater usage studies on, again, something that would be hard to observe in the real world, how much water is being used, especially in a short time period. So we've got work there. Steve's been doing some great work with the bobolinks and thinking about, conservation markets and how do you, have timing of conservation contracts. How do you look at the provision of public goods with thresholds, right? So we think that we not only need to provide some environmental good, but we have to get over a certain quality, right? In order to really be meaningful for water or for habitat or such stuff. So there's been some really good work that's been there. The challenges of water quality trading, how those markets generally haven't come together, again, is an opportunity for experiments to look at. And then there's been a robust literature by Parkhurst and Sjogren and others to look at agglomeration, right? And Semanti Banerjee's been working on this. How do we get conservation clustered together in a way that can protect habitat or do other environmental services that are spatially linked together? So, a lot of these experiments are really driven by the labs, right? Almost labs with students. A handful of them start touching with farmers or landowners, but it's not very many. And then several of us have been pushing off into the field experiments, and Steve hopefully will talk about his work with the bobolinks and the I think it was the Audubon Society up in the northeast of the United States to try to get farmers to actually put these ideas into practice and some of the challenges that occur there. So that's kind of the quick 2 literature reviews that we'll be hitting on, and then we move into thinking about, for new researchers, how do you design something that is meaningful for policy and the applied nature, and of course something that's meaningful as well for our own literature within academia as well. So let's take a quick moment at a 3-dimensional diagram for that we kind of lay out here. One is the classic experimental control. So Lusk and Sjogren really talk about the importance of having no unmeasurable external forces occurring, so we can really get at the idea of cause and effect of experiments. And so that's the kind of classic thing that we like to see with our experiments. So we can imagine some programs having low, some going up high. We can kind of expand that. So we'd like to think that this is one of the advantages of an experiment. We could also think about going from low to high in terms of the context of the decision environment. Again, if we're talking about some of the original experimental work, you'd be thinking about making decisions between decision A and decision B. Well, if we're talking about conservation, we could be talking about different types of conservation practices, no-till practices or high-till farming, right? Or you're going to put in a buffer strip or no buffer strip. We could put things in that helps someone understand the environmental context. But that could have some challenges too if we start using the word taxes, where people may be more comfortable or less comfortable with that. So maybe having transfers would be something that's less context rich or not. There's kind of an active debate on whether these things matter or not. But you can imagine, again, we can go from low to high in this realm, and likewise we can really look at representativeness. And so work by Lori Lynch, Josh Duke, and I talked about really trying to think about the representativeness of a sample. And to what degree will policymakers see this as valid? And this is maybe a concern of our undergraduate students being the sample. But if we have farmers in Indiana making these decisions, or farmers in Vermont making bobolink decisions, we might feel a lot better that this is something that's representative of things. And again, in the developing world, where we've seen a lot of the work in this area, these things are well represented. You got a lot of the small landholder perspective being represented. These are part of the sample themselves, but not so much in the developed countries. So if we take that 3-dimensional world where we can understand where does an experiment fall under? And we begin to lay out 4 different stages. And I put 2 different stages as part of one because I kind of see them as the same idea. These are kind of our classic lab experiments with our students, and they're high in control. They're high, but they're really low in representativeness. But they might or may not have context of decision, right? You could use things as just accounts 1 and 2, or decision A and B, or you could be putting people as, assume you're a farmer and you're making decisions, and your land has some, productive parts, and then it has some, pollution that flows from it. So we've seen both of those in the literature. And maybe that's where we start with understanding and testing mechanisms. But then the question is, how do we go a little bit further? How do we begin to, bring in landowners in stage 2? So this might be a mobile lab, or maybe a setting that's more rural than most of our campuses are, where we can bring people in and have landowners. Again, not many experiments have been in stage 2, or they've had really small power. Stage 3, it says, okay, now we're creating experiments out in the field where people are making decisions. Again, Stephen's work on bobolinks would be an example of that. Some of the sea bear work with feral hogs and irrigating farmers in Colorado and Georgia are examples where we set up their own program. And then kind of stage 4 is these randomized controlled trials that are hopefully built into USDA programs or large scale programs. And then they have administrative data that are there. So you can really get the sample up higher. So again, thinking about these things, and then we guide our discussion throughout the chapter about the pros and cons of this, right? So cost might be an obvious one, right? Stage 1 and 2 might be a lot less expensive than stage 3, could be very expensive. Stage 4 could be cheap if you can get the cooperation of the agencies, right? So you might be able to build within the agency, but there might be some additional challenges. So the pros and cons of all of this there. And that's how we begin to look at the contemporary issues, best practices, and recommendations. One of the key things we'll talk about is the challenges of small sample sizes, because that's been plaguing experiments for since their beginning, right? And so Paul Ferraro and his co-author have this example of looking at loss framed contracts, right? And generally you see the literature to the right saying, yeah, there seems to be some positive behavioral incentives by having things framed as a loss. And you can see that the standard effect sizes seem to be, relatively small, but large, but sometimes you see some really large, error distributions as well. And so they did a creative way of showing this in kind of a pyramid diagram where your larger standard errors are on the bottom, a little kind of counterintuitive, but it works out nice in this example. And then your mean differences of your effect sizes to the right. And what we see is, a number of studies, again, showing that on average, these studies look like these loss framed incentive contracts seem to work well. It doesn't seem to matter so much if it's a field experiment or a lab experiment or stated effort. But what we see is when we start looking at the sample sizes, some interesting patterns here. One is some of the early work in this area had very small sample sizes. And so in order to see a large, to see a statistically significant effect, you have a really large effect that was there. These are kind of these are kind of, estimated maybe correctly, but it could be that also you got kind of a statistical anomaly. What we see here is the ones that show very small effects or even negative effects tend to be large sample sizes, right? And of course their standard errors are smaller. So we see this interesting cluster. And then of course there's this bottom left here, which is another fascinating, seemingly missing part of the whole literature, which is small samples that didn't show an effect or maybe showed a negative effect on these things. And why don't we see them? Well, publication bias would probably knock most of these out, either self-censoring, people not even trying to submit them, or they get submitted and they're not accepted. So again, a challenge of looking at some of these behavioral insights might be really promising. We've already said we're concerned about them because they're at the individual level and they're small stakes relative to agro-environmental context, but then we got to get to the right scale and the right size. And so that's something that we don't feel has been well known in the literature so far for our world. Again, I think the developing world, RCT world, has been much further along than the experimental economics in general there. And so we've seen that power has been a big problem with studies, a lot of the statistical power being less than 18%. is not very good. And we also recognize that even though experiments were kind of sold on this idea that replicability was going to really, really matter, it rarely happens, right? And it's hard to get funding for it, hard to publish these things, especially top journals. There's been some change to that, but it's still small. It's interesting. Here's a couple of examples of editors that have commented on our papers at CBER and others. Here's an AJE editor commenting, that the small to no impacts of a treatment reduce the contribution of the paper. Now, keep in mind that this paper had 46,000 producers looking at the conservation reserve program, so a very large sample. And if it didn't have an impact, that probably is really important, at least from our perspective, to understand whether this is valuable or not. And then reviewers 1 and 2 wants to see if we can parse the data out some more and to look for a bigger impact. We had another paper that talked about it's really important to look at null results, and so they liked that idea. But we need to understand better the underlying mechanisms of these null results. Well, it seems like the burden is high that they assume there's always going to be a default or a peer effect. So if you come in with a large scale, I think there's 1,000 conservation districts in the country, and then we had to prove what the underlying mechanism for when there was a null result, instead of kind of like saying, well, we didn't, maybe it just doesn't work, right? So again, there's this bias that exists there. Another big challenge is looking at farmer recruitment. And I think people have been working in this area know this well. We have this new paper just came out in Applied Economics Policy and Perspective last month that showed some of our results where we're getting under 10% participation. Now, keep in mind, not everyone participates in all the agro-environmental programs within USDA when the incentives are high. But again, this is very difficult if you're talking about less than 10%, even 0% for some of our email treatments. We've done a variety of things. We were trying to recruit farmers to participate in an irrigation study. We did personal phone calls for 2 weeks. We increased incentives from $50 to $100. If you're not seeing much there, that's because there doesn't seem to be much there. I mean, in terms of getting more and more people to sign up, yes, it was happening, but not to the level we were wanting to, given our pre-analysis plan and so forth. So really challenges with farmer recruitment. I know that people like Samanti and Stephen and others have had a lot of challenges there. And I think this is a limitation there. And so, I know I'm going to run a couple minutes over, but I want to make sure I end strong and make sure it's clear. Is I think that we partly have another challenge is if we think about stage 4 research, the idea of partnering with a government agency or a large nonprofit, partly we have our academic loading dock problem, right? So here's our beer falling off our loading dock because by the time academics come along to delivering our research results, maybe the conservation program's already been launched, or they didn't even back up to think that we had any insights. So we have this constant problem with how do we really make sure that what we're doing is valuable from a conservation practitioner perspective. And then my slide, which I feel like a Charlie Brown in this one, which is working closely with USDA or others, lining up that perfect winning field goal, and then having them pull the ball out when suddenly their study doesn't, the program is not going the way they wanted it to, or they're worried about some farmer in New Jersey complaining, even though we're rolling it out to 30,000 farmers, and so suddenly you don't have a study because you have to have such collaboration with everyone. And again, if there's changes in administration, you've got changes in priorities, setting these things up and running them at a large scale can be a really difficult thing, and even getting access to the USDA data is a real challenge. So. These are challenges, especially for junior researchers entering in this. And we'll talk a bit about that because I think it's been pretty common. I'll just give one little example here. Here's USDA's Economic Research Services Gateway document for experiments, right? So hopefully I won't get in trouble by sharing this. But they've got 4 different stages that have to get through approval before they can run an experiment. And I'll highlight a couple things. One is you need to get approval from the Economic Research Service and USDA collaborators. And so you got to have commitment from your research team and all these different agencies. And then it has to, before it goes out, has to be reviewed by external and internal reviewers. I'm generally in favor of that, right? Let's have better review of our designs up front. So I think that's really good. And I think it's a really wise approach, but again, requires more delay and time to get that through. And then we're going to have both institutional review boards, if it's through academia, and the Office of Management and Budget clearances. And these are separate processes. And then once we launch it into the field, all field offices can be fully informed. There's 10,000 field offices within NRCS and FSA. So how are you going to fully inform them? These are high challenges. Again, you're going to have a really nice experiment, but again, it's very easy to get kind of caught up into the gears at any one moment, especially if there's a change in administration or priorities. So where does this leave us? So where are we at? We're going to try to come up with recommendations. Again, here's a spot where I want to throw out other people's recommendations. Get feedback would be great. We want to emphasize in this chapter the importance of conducting a power analysis before you're running it, making sure that we avoid these underpowered designs that have been plaguing our field. And let's pre-register our experiments and our analysis plans. Let's go ahead and think about the heterogeneous treatment effects and make sure that we're accounting for those things there. I know a lot of our USDA colleagues would like to see a more standardized set of participant demographics and characteristics being captured in our publications, so that from a policy perspective, it's easier to imagine how these things are going to impact small farmers or minority farmers or things like that, so that our research can be more relevant from a policy perspective. And then let's detect, let's assume we're going to have small effect sizes and design our studies to detect those. So we need to do that. Let's account for multiple hypotheses and use a proper econometric. We won't go into all these details now. And then report these things well, so that we're, again, clear about that. Another thing that we're going to talk about is the ethics of conducting studies with farmers. Keep those in mind as well. For many of us, we have to really recruit with our extension agencies, and so we're going to have to make sure that we're protecting those relationships as well, so that the farmers see us as a valuable source of information impacting their policies. But there might be many more times we're interacting with the same people than we would in a consumer study, right? Where we wouldn't have to worry about that in the same way. And so we'll have a kind of more of an ethics side of things that we want to highlight. We've got a couple recommendations for editors and reviewers. One is just to understand the importance of design up front and the importance of questions, and don't put such a high emphasis on statistical significance, and recognize that when you have a good powered design, null findings may also be valuable, and then encouraging replications. And finally, encouraging the funding agencies to be more demanding in terms of power analysis and pre-analysis plans as part of grant proposals, and then be realistic that it's going to cost a lot of money, especially to move into those phase 3 designs that are there, that you're going to have to, cost a lot of money, and you might not be able to test as many things as you think you can because of multi-hypothesis testing. That we have to, can't promise the world, but we got some important things. So again, maybe using those stage 1 experiments to help highlight the key things that should be tested in further designs is going to be important there. And then ultimately, how do we, can we really expect researchers to go from phase 1 to phase 4, or how do you fit into those models so that you can really be informing policy and program is the best, and what level each kind of program or study is hitting on. So, that's kind of our quick summary. I know I ran a couple minutes over, but again, we look forward to comments and insights.
Fantastic, Ken. Thank you very much for an extremely rich chapter and presentation. So we're fortunate to have Stephen Swallow available as the discussant on this. Stephen, let me turn it over to you.
I'm going to try to share my screen here.
Kent, I think you'll have to stop sharing. There you go.
Yeah, I'm continuing on that and hopefully having oh boy, now my buttons are blocked. So Kent has somewhat challenged me to speak a little bit about my research just now, and I wasn't intending to, but I did slide in a couple things. But I hope everybody can hear me all right.
Yep.
So, basically, I'm just intending to do a bit of a review of the draft of the chapter that was available to me. And I really don't have any great points of disagreement with what Leah and Kent have put in the chapter. So, but I am probably going to say too much about some of the comments he's made, a little bit about the standards of practice, especially around power analysis and pre-analysis plans, just because of my concerns. But before I get into that, I want to say a few other things. I think that the chapter is going to provide a good overview of the practices and challenges for testing existing policies. And while it's there in the draft now, and certainly in his presentation just now as well, I do think that we can ask for a bit more of a push on how experiments, and I say experiments, I guess I mean behavioral and experimental economics, but I'm going to, out of habit, probably say more experiments when I go through this, can actually push policymakers and create suggestions for new policies and test bed suggestions. And I'm wondering if we can't ask the authors to develop maybe a more extensive set of examples. I think they have a plan for that. Examples of studies that have sort of pushed policy, because I see that they have an appendix that's, sort of indicates a list of those kinds of examples that aren't yet, at least not fully developed in the written version. Can experiments invent policies? Can we get into, my area is getting into ecosystem service markets and private provision of public goods. There's things like co-benefits for cap and trade that can happen, say with water quality credits, when farmers are taking steps that create water quality credits. Oftentimes they're also modifying a landscape or modifying a habitat or sequestering carbon. And even though there may be carbon sequestration markets out there under regulatory cap and trade markets, sometimes those things are separated. As we see with the Ohio River water quality trading that I've worked with a little bit, where the farmers really can only sell the water quality credit side and not really any of the co-benefits, even if there's a credit market, such as in the case of carbon, that may exist. But certainly for some of the more challenging co-benefits, can we do some research that helps identify better ways to, expand the policies, not just and certainly Kent's not focused narrowly the way I might be implying here, but I guess I'm pushing for the chapter to more strongly encourage, academics to really just push the policymaker, create more options, while also, of course, paying attention to the options that have been created and evaluating those policies that already exist. One of my favorite pet peeves is some of the USDA policies that seem to be motivated by avoiding letting farms get paid twice for the same ecosystem service, avoiding double dipping. But I think some of those policies inhibit the ability to leverage joint products in an agro ecosystem production. So I'm wondering if we can do more like that. And so quickly running through a few slides, because Kent sort of challenged it. Our Bobolink project is about, it was motivated initially by non-market valuation work, but getting people to not just tell us what they're willing to pay to conserve the Bobolink, but to actually look at payments and how might a total revenue curve change over different ways of soliciting actual payment that would go to farmers. And in fact, this is from the original iteration of the project. It's, we've actually tested an auction process sort of motivated by Lindau pricing that we all think is impossible to implement for public goods. And it's actually yielded a business process that's been patented by the U.S. Patent and Trade Office. So to me, this is at least, while it's not in the paper cited here, it's at least an example of some academic work that has pushed for, I guess technically an actual invention of a new approach that might help with, in this case, private provision of public goods. And then the co-benefits, we've done some experiments with the water quality, where the bottom part of these bars is getting at the willingness to pay for what the underlying water quality credit, but then also splitting out some willingness to pay that was measured experimentally under different treatment mechanisms. Whereas you go to the right here, we're getting closer to incentive compatible conditions. And we're separating out willingness to pay for some of these co-benefits that are jointly produced in agroecosystems related to water quality cap and trade policies. Also, another project I've been involved with has been trying to, this is a project that's been done with modeling rather than experiments so far, but it's trying to expand the use of cap and trade to something we initially called water supply capacity credits. And I think we could use some experiments to see whether there's a way to try to operationalize the idea of paying landowners who have undeveloped land, which could be a lot of agricultural land. And the context here is the Northeast. This is a watershed in Connecticut. Paying landowners to recognize the value that their undeveloped land may have in capturing and making available water for supply of in the Northeast case, residential communities. So in the bottom of this watershed here, there's a fairly significant residential ex-urban community that's drawing its water supply from all of this land, and yet as they approach the full capacity of the watershed to support the human population, there's really not a good way to balance the water uses to acknowledge the historic uses with the continuing to increase residential demand. But continuing on, some of the obvious advantages here that Kent and Leah have put into the chapter is, experiments can identify causality and ways that we can inform human or improve human well-being. And the message of controlled tests can help assure the effective use of taxpayer funds or nonprofit organization funds. I think that we really need some examples. Hopefully, I don't know if any exist. I've actually emailed a colleague who has unfortunately not gotten back to me yet, but some examples that might help quantify how have experiments, whether they're lab experiments or randomized controlled trials, how have experiments helped redirect and potentially save money, save costs for agencies implementing different programs, or at least improved cost effectiveness? Can we quantify some of that? Can some of that be in the chapter? Are there at least some examples? Maybe that'll be, my colleague is Nathan Fiala, and he does a lot of work in developing nations, especially in Africa and some in Asia. I'm wondering if there's examples where we can provide some convincing numbers that at least cause agencies to be more willing to support, getting some sort of experimental evaluation of their policies into the system of implementing the policies, or designing them or redesigning them. So is there a way to push back on policy makers or agencies that have shown some reluctance? There's some concern about ethics is raised in the chapter, about the political structure for implementing public policy. Some of the decision makers may be concerned about equity for participants because, of course, some participants might get assigned to a new program that may turn out to be beneficial, and others may be assigned to something resembling a control group of, you know, no change. So they don't, by random assignment, they don't necessarily get the immediate benefit of a potential new program. But, you know, in the IRB world, in the Institutional Review Board for Supervising Human Subjects Research, you know, the fact of random assignment means that there's equality of opportunity across research subjects. So I don't know if there's ways to develop these arguments or better arguments. I'm sure I hope there's better arguments than I've come up with to try to really get the public policy agencies and even the political decision makers to look into you know, more dedication to experiments to evaluate the programs. I just want to quickly throw out that, you know, challenges in recruiting farmers. One thing that's made it, I think, a little easier and a little more challenging is that social media can help you reach out to lots more people. But it also creates a pathway for a farmer who may be having a strong opinion to express that opinion and, in a sense, poison an entire potential pool. I've certainly experienced that, fortunately in a small scale experiment, but nonetheless, it's damaging. And then also that kind of event can be damaging to, say, some the programs of say, some outreach or extension specialists that might be collaborating with you if that happens, because it can challenge the credibility those farmers give to that assistant in helping you recruit. I am interested in the trade-offs, and I appreciate a lot that that Leah and Kent have taken some effort to explore the trade-offs between setting standards and recommended practices. But I am really concerned that chapters like this could become a piece of ammunition where editors or at least referees start to expect minimum standards that can become very constraining. And I look back at examples from the stated preference literature with the NOAA Blue Ribbon panel that was convened after the Exxon Valdez oil spill, that came up with lots of guidelines about how stated preferences should be done. And then, of course, the more contemporary guidelines from the Johnston and Adel large group of stated preference researchers in the ARI journal. You know, both of these groups were, and I'd say more extensively, the Johnston et al. Group were careful about recognizing that recommendations, if all different recommendations are going to be implemented in this area of research, well, then most studies would become prohibitively costly. And I worry that can start happening in this area. It sort of has to some extent. So I guess what I'm trying to do here is generate a little controversy. You know, I certainly believe that power analyses, pre-analysis design plans are important and can raise standards and practices and raise the quality of our studies, but they can have unintended consequences. We need to be sensitive to those trade-offs and look at the net gains in a policy context. So I'm looking more for elaboration here, and I have a number of slides. I'm not sure, Chris, maybe if you can interject how much time you want me to use, like another 30 minutes.
Yeah, we might want to give others a chance to comment or ask questions. So if you can wrap up in the next couple of minutes.
Okay, maybe 2 minutes.
Great, thanks.
Okay, so I guess I'm worried that some of these standards around power analysis and pre-analysis plans can cause unintended incentives that can feed publication bias. I certainly think that authors should be asked to consider the advantages and disadvantages of their methods and make sure that whatever they offer in a study is is set in the context of what is more strongly supported and what might have been an idea that they explored after some of these plans were filed, but still meets some standards that referees could be accepting, particularly in our other specializations. So I am pushing for, you know, clarity of context and transparency, trying not to overly restrict the creativity of authors once they've got some experience, and making sure that the presence or absence of the higher standards of quality research are elucidated in a study, but not necessarily creating incentives for authors to hold back on some good ideas that frankly could help our profession move forward. I think, for example, even if some let me say results with weaker support make it into literature, I think if the context is right, that's not necessarily a bad thing, especially since you know, more challenging, more controversial policies, or policies that have perhaps even more flaws because they were implemented quickly, those might be attracting multiple people to do studies in multiple different angles of evaluation, and I worry that oversubscription to some of these standards could limit the ability of future people to start drawing on meta-analysis techniques, for example, to draw out and see what more might be available from studies that have been done. Again, I'm not trying to argue for weak studies. I am trying to argue for author latitude, I suppose. Let's see. So, you know, again, I appreciate that Kent and Leah have acknowledged some of this. You know, no experiment needs to do it all. But I'm also concerned as well that in order to meet some of these high standards, you know, we end up with, you know, doing, whoops, that didn't work. With this third bullet point here, you know, pushing studies that take smaller steps with perhaps a high degree of confidence or validity, but then we're left with maybe a slower moving train, because some of our social challenges actually might benefit from a faster pace that addresses greater steps, although albeit with some weaknesses in the confidence that we can get if the study is less well controlled, less well circumscribed for what it's offering. I think I'm very close. Yeah, I'll just let the rest of these go.
Yeah, maybe you can share your slides with Kent and Leah.
Yeah, exactly.
And I didn't know if Leah, I don't know if you're in a position where you are able to join us, or if you want to jump in and offer any last comments to echo or reinforce things Kent raised, or cover anything he left out.
I'm going to just jump in. She is listening in, but she is not able to join in the conversation. Well, the one comment I'm getting from her is, you know, that she appreciates the trade-offs between rigor and innovation, and so I think that's a great point, Steve, and that Leah likes. And I think one thing we could look for feedback on is, you know, I think the idea of emphasizing the policy innovations makes sense, and I think that's good. Leah was questioning, you know, really should we be targeting it for the policymakers, or, you know, the researchers and academics who will be the target audience? And so she kind of raised that question for some further feedback from.
Yeah, so the audience, I can speak to that last point. The audience for the handbook are researchers. So it would be the uncommon policy maker or even policy advisor who's going to sit and read handbook chapters. So the real intended audience here are PhD students and faculty and postdocs who are looking to get caught up on the most recent developments and the history of thought behind the current research frontier. I was really excited by the ideas you were raising. It's fascinating to me as somebody who pays attention to some of these things in the international space, what's happening or not happening in the domestic space. So I completely agree with you. There's a lot to be learned from the intellectual arbitrage between those two communities, and it sounds like you guys have already been involved in a little bit of it. One quick thought I had, or actually two different thoughts. One, I'm super pleased to see your emphasis on ethics. This has been a serious Achilles heel in the development economics literature that rapidly embraced experiments, some of which were ethically dubious and have caused significant risk to the profession as a whole, as well as risk to human subjects, to participants. So I strongly encourage you to emphasize that and explain it. Anna Josephson and Jeff Mickler at Arizona have a nice food policy paper a couple of years ago, and a special issue of AEPP coming up dealing with ethics in agricultural and resource economics. And I encourage you to perhaps check that out. The only other observation I would make based on the development literature is an awful lot of the behavioral literature could be grouped under the heading of how do people learn and what is it they really learn about, and from whom do they learn? Because we commonly have models of learning that are based off of some imagined kind of Bayesian updating of beliefs about profitability. But it seems that people respond to lots of social signals and moral suasion and things that really have very little to do with profitability of a technology, for example. And this seems especially salient when dealing with agro-environmental issues, where trying to understand what motivates people to adopt no-till practices or whatever it might be to kind of improve water management, what is really behind their learning process and how much of that is social or non-economic in its underlying motives. There's a bit of a literature and development that starts to edge into those issues, which seem especially salient in your space. We have a few minutes left for any questions or comments for Kent. And thank you, Stephen, for an excellent set of discussant remarks. If you'd like to pose a question or comment, please just use the raise hand feature. Meanwhile, I don't know if you have other reactions to, Venetia has a question. Venetia?
Thank you so much for this presentation. I was just wondering, like, with respect to recruitment of farmers, how do you suggest we deal with the selection bias problem that only a certain type of farmers are willing to participate in certain experiments?
Yeah, that's a great question, Venetia, and thank you for bringing it up. I have kind of two different ideas. One is, if one can, keep in mind that for the agro-environmental programs, there's often a selection going into them as well. So you want to think about, I think in the United States, we think that any given conservation reserve programs, less than 10% of farmers or something like that are landowners. So, it may not be as horrible as you think, because that's what's happening in these programs to begin with. So if you're really only getting the people who actually are participating in these programs, then you're actually getting the right target. Right, so that's good. The other thing is to sometimes try to measure, like we have a project out in Colorado that we're self-selecting on it, but it's use of aquifers and groundwater. We're going to compare that to what's publicly available, so we can get some type of sense of how bad is our selection process, right? So we know we've got a small subsample, but can we get some other type of administrative data, right? And that's really where we can draw from, saying, okay, this isn't so bad, or look, we really only have the friends of the extension agents, right? That's the concern, is you have the early adopters that are there. And I think that's a key question. So if you can, again, that's what, the dream is, if we can begin to work more and more with the programs themselves and embed the experiments in an ethical manner with it, then we can avoid a lot of that. So your point is there. It's true with all types of experiments and all types of surveys, but you're right, it could be a big problem. Just keep in mind what's that specific context and how big of a problem will it potentially be.
Thank you.
Kent, do you want to touch on the rather controversial issue of deception in experiments, especially when running field experiments?
Yeah, I mean, I'm not a big fan of it. I think that the downside risk is so much higher, and I think that's where the ethics, right? Again, we're talking about a group of people. It's not that many, and we have a hard time getting them in part of studies. And now we're doing active deception, right? I mean, it's one thing, it's omission of information, but even that can upset some people. I'm very reluctant to do that. I think that the papers that have been out there have really talked about, it should be avoided at all possible costs. There might be times where it's the only way of getting at that information, but then you still have to evaluate, is it worthwhile, right? Is that level beyond just a nice publication for our vitas? Is this, societally, really important or not? So I shy away from it because I think the long-term damage could be quite high.
But you're not against necessarily having one treatment group have information about their treatment, but not information about all the other treatments, or even information necessarily about what the main hypothesis is that you're testing.
Yeah, absolutely right, Stephen. So maybe I overstated what I just meant, but no,
I just want to be careful because I have had the experience where referees called that deception, and I bristle to think that the standards for deception are that low.
Yeah. And Stephen, I appreciate your points about be careful about setting the standards, right? Because I remember John List talking about field experiments once. I'm like, oh my God, I'll never have a career. I'll never be able to raise enough money to do all these field experiments. Now the power analysis gets quite expensive, and we've been lucky to be successful at raising grants. But I'm very sensitive to junior researchers, and we'll have a section in the chapter talking about what do you do as a junior researcher where you can't be running tens of thousands or hundreds of thousands of dollars of studies. How do you contribute to that literature? How do you build? And I think that's important. The other thing will probably emphasize as well is right now USDA and others run uncontrolled experiments in which there's like no evidence that it actually is the right treatment, right? So it's not clear that if we actually treat farmers in A and B that we're actually, not better than what we're doing. We're just treating with A, and it may be a really bad policy. So this could be something that really is good for farmers. And we've been looking at ways of trying to make that case that uncontrolled experiments and rolling them out and spending $6-7 billion a year isn't a great process. And we would never suggest that that's what we should be doing.
Great. Well, there's Alicia Hartley has a comment in the chat box. So Kent, let me encourage you to take a look at that. But Alicia, with apologies, let me not ask you to unmute because we do need to transition to the next section. So thank you very much, Kent and Leah, for an outstanding presentation. So an exciting chapter. And thanks so much for your very rich comments, Stephen. I hope you'll share your slides with Kent and Leah. I'm sure they'll benefit from them. So let me turn it over to my my co-editor on the volume, David Just, who's going to moderate this next session.
Okay, thank you, Chris. And that was absolutely spectacular. Thank you, Kent and Leah, and also Stephen Swallow. We have an exciting hour ahead. We will be hearing from David Hennessy from Michigan State and from Tom Marsh at Washington State University. They'll be talking to us about the economics of animal health and livestock disease. And so I want to make sure I get out of their way. Hopefully they are here and they should be able to share screen at this point. Ah, there's David.
Hi.
Yes.
Okay,
Okay.
Is that shared?
That is shared. I can see it. Yep. So I'll give you 25 minutes or thereabouts, and then we will hear from your discussant.
Okay, so how we're going to do this is I will do the first half and Tom the second half. So we will try to pass the baton without dropping it. We'd like to thank Chris and David and the Handbook people for this opportunity. this is the abstract that we sent in. I'll give you a short while to look at that. I think we have covered, or we intend to pretty much do what was suggested back 9-10 months ago now, but there have been some modifications when we reflected on how everything fitted together. And the tentative layout is going to be an introduction, which is yet to be written, a section on-farm damage control, which there is a draft currently in the editors and Chris Wolf, the moderator's hands. Section 3 on externalities, which is an almost complete draft, is out there now. Disease management case studies, which will be both Tom and I, and it's not written yet. Trade, Tom has a draft. And welfare issues, Tom has provided a draft, and then just an overall discussion on gaps and new issues. And then the layout, the rationale for the organization goes as follows. We view things as starting, at least the need to understand what's happening on farm first, and then as the most problematic diseases are infectious, we deal with infection and externalities, and then those two together go out toward the how to redress them, public animal health schemes, and consequences, trade and welfare issues. And then we'll seek to bind those sections together and learn lessons from them to bring forward to a data gaps and new issues section. And the basic approach is, where possible and what we think is being useful, to have a small basic model to lead off of, and then use that to discuss issues and where the literature stands, and then move forward. So the basic model in section 2 is not actually one model, but two models. The first being the Lichtenberg and Zilberman model on damage control, which has been used far more widely in the crop literature than in the animal literature. And of course, it didn't really deal with infection issues. And our adaptation of that is to have regular inputs, which we will be called Z, and then the damage control inputs. So output is going to be potential production, F of Z, multiplied by the fraction of that potential production that is actually produced. That's the damage control part. And you have a loss function and a control function, what we call a bug control function, there as part of that fractional loss. And so the issues are to choose Z, the regular inputs, and also X, the damage control inputs. At least that's the farm level set of choices. And then we go on to discuss a model proffered by McInerney in 1996, which essentially talked about endogenizing loss. So forgetting in his model there were no regular inputs, but just studying the trade-off between abatement costs and loss. So we talk about all of these matters, and an example here is the two sources of losses in the McInerney model. We have a disease loss. The green declining line is a function of abatement input X on the horizontal axis. So if we look at the left panel, panel A, there's an interior solution in terms of abatement input. And then you have the abatement costs. And there's a trade-off between the two. You seek to minimize loss or expected loss, however you want to manage it or present it. And then there may possibly be, and it's often the case, if you go to panel B, corner solutions where the abatement cost is too high, or perhaps there's no abatement opportunity, and then there's a total loss because there's no effort to manage the disease, or alternatively, abatement cost declines to such a level that the disease is entirely managed, and it's done so at what amounts to pretty much a fixed cost. And then we go from there to talk about protection and or cure issues, adapting this little model to deal with when a disease is known, and you can adapt your circumstances to apply abating only when you know that there is a disease, so sort of a real option flavor to it, and allowing for diagnostics tests and quality of tests and that kind of thing. And then we talk with moving away a little bit from that model about the production economics of insurance and private information at the farm level. We talk about loss assessment, the three standard approaches to doing so, the pluses and minuses for doing so. And we talk about production structure, how animal health might affect the capital to labor ratio on farms and that kind of thing. And we talk a little bit about antibiotics as an input. And all of those discussions are to bring in the literature. And then we move on to section 3, infectious diseases, and this is in several parts. It's a longer section, at least as presently drawn out. The first section is endemic disease, and we lean heavily on the standard model of the commons with a twist, and the twist is that we allow for free entry. So we have a simple Nash behavior model with a zero profit condition, so that herds can enter into this disease commons if they wish. And the simple model is just profit at the farm level as a function of own action, which might be thought of as stocking rate, multiplied by a loss function, which can in a way be thought of as the loss function coming out of the earlier section, but now the actions that determine loss are not on that farm, but rather on farms in that region, as denoted by A sub capital A sub I sub not I. And there are costs for this stocking rate, both variable and fixed. And this H function, the damage function, is positive, decreasing, etc. And what falls out quite readily from this model, it's basically an adaptation of Mankiw and Winston, a famous paper in IO. Too many herds, stocking rate too low, and productivity too low. And then we go from there to discussions about substitution, basically the beggar thy neighbor, tragedy of the commons, social distancing policies, as in contracts and that sort of thing, trade within this sort of a model, and stepping somewhat out of the model to capital valuation perspectives when thinking about how on-farm choices are made when there are disease externalities. And then we move on to, within that section, exotic diseases, and the basic model here is weakest link pure entry, Kramer's O-ring model, more famous from development economics, is sort of the launching pad for that. And then there are two other papers. There's a paper by myself of 2008, and also a paper by Reeling and Horan more recently that we base our simple models off of. And here's the first case. The weakest link pure entry version is basically each player within a region has an opportunity to block entry, and the product of their successes determines whether there's entry or not, and that generates very strong complementarities between actions. And the consequences of that are that there may be multiple equilibria, and you want to engineer the best from those multiple possible equilibria. How do you do so? Talk about learning and leadership and principal agent modeling, seeking to do so. And the Reeling and Horan model works through, allows for an indirect route as well as the direct route, and that's more sophisticated in the sense that in some sense, because you can get the, if disease enters, you can also get it from the neighbor shortly after it first enters. You have both a direct entry, an exotic disease component, but also to some extent an endemic disease component. And the result is that whereas endemic disease emphasizes the idea that you may be free riding off your neighbors, and direct entry emphasizes the idea that you may you're all in it together and you have to work together to prevent entry. In this setting, there's a bit of both, and where you end up can very much depend on how people think about where they are, which is the main point in Reeling and Horan. And so that allows for discussions on stamping out, and there's a large literature there, some of it to do with Olson and Roy papers about 12 years ago. Some discussions on borders. Fernandez and Sheriff have a paper, information and tracing, which would be to some extent motivated by some issues to do with BSE in the US going back 15 years or so, and also some food safety work about the roles of information in helping to mitigate problems. And we'll talk a little bit about vaccination. Neither of these two parts of this chapter have yet been written. And then we go to disease management, and this section has not been written, but we would talk about public animal health, endemic and global campaigns, talking a bit about global infrastructure, OIE, FAO activities, about some case studies, TB and brucellosis eradication, Jonas disease programs around the world, NPIP in the US as an example of a quite a successful program, HPAI globally, and there has been some work nationally and also more so globally about HPAI. As a review, the only animal disease that's been completely eradicated, rinderpest. FMD, foot and mouth disease, is a huge source of literature in this area. And we'll talk a little bit about zoonotics here. Our ideas on how to introduce or manage zoonotics are not wholly formed. So in this area in particular, we would all, be all ears to hear what the audience has to say. And then talk about private sector and investment issues in the presence of such diseases and the threats of such diseases as a case study issue. And now I'll turn over to Tom.
All right. Thank you, David. So, do you want to just shut your slides off and I'll reshare them?
Yeah.
It'll be easier that way.
I'm having a little bit of a problem with my cursor. I want to curse my cursor. I can't, I'm working two screens and it's not, okay, hopefully. Does that help?
If you can go to the start of section 5, you're still sharing.
I can't get my.
This is David. Let me attempt to stop your sharing and see if that helps.
Perfect.
Thank you. I think we're okay. Now I can. I have multiple participants can share.
Good.
It looks like it's up and running.
Okay, great. Thank you. Both Davids. So I'm going to talk about Tom Marsh, Washington State. I'm going to talk about trade and welfare economics a bit. This will be an animal agricultural focus. So if you have other thoughts about wildlife, etc., please let us know. Generally, I'll be thinking about where we've been, where we're at, and where we're going. And in my mind, I partition this into kind of some post-infection and then pre-infection. And like David said, we're kind of using simple models to motivate how we're doing this. So I always like to start this out because some people aren't fully aware of how livestock play a role in both food and food production. And so in 2018, if you look at the FAO data, 4 livestock and livestock products were ranked by value in the top 10 commodities. Number 1's rice, followed by fresh milk, then cattle, pig, maize, and then poultry meat. So in terms of value of production, it's very large, right up there with any crop. And then if you look at trade actually as well, and you combine the meat products, then meat as a commodity is right up there with soybeans and grains. The other point is when you look across the world and not necessarily in the developed world, but livestock and livestock products are important sources of food and nutrition across the world, and sometimes really the only source of nutrition. Okay, so I'm just thinking here is a post-infection trade model, and I have total supply. That's made up of domestic, I'm going to get my spotlight here, sorry. Domestic supply, all your suppliers and your importers. So your total supply to a region or a country is your domestic supply plus your imports, and then total demand. You're going to have your domestic demand plus those in your exports. And so this is really just common in the literature using demand and supply relationships to analyze trade. And then, of course, if you go to an equilibrium point, then you have to think about your market structure. And right here, I'm just going to use the example of thinking about a large open country exporter. I could think about small countries, but I'm thinking about large open country exporter. And I have domestic demand and supply that are pre-infection. That's D0 and S0, and I'm going to show a figure in a second. And then I have excess supply, E sub 0, and excess demand, E sub 0. And so the sub zeros are really my pre-infection, and the ones I mark with a 1 are going to be post-infection. So in this case, I have equilibrium price, which is going to be at P0. That's from the intersection of the excess supply and excess demand. And I will have the amount consumed within country is Q0 and total supplied in country, now it's countries QX0, and then I just have what I in terms of exports. So why do I want to bring this up? Well, historically in the literature, you know, one of the things we think about when evaluating the consequences of animal disease is say supply shock, and here I'm thinking about stamping out. And if I have stamping out only, then a simple way to think about this is that it's a shift of the supply curve to the left. And what may happen here is because I shift the supply curve to the left, excess demand also shifts to the left, and I end up with a higher price. So you can think about over here, consumer surplus, that consumers are worse off if that's how we measure it. Producers, well, it depends on if you've been infected or not. So if you're non-infected, then you may be better off because you're going to receive a higher price from your product. But if you're infected, you're likely going to receive a worse off. So there's some ambiguity there. Next thing is the thing that historically comes up is demand shock. So you may have demand shifting down here. And if demand shifts down, you know, the classical case is that producers are worse off and consumers may or may not be worse off depending on whether they quit consuming or they just reduce their consumption. And then finally, we always have to deal with trade shocks as well. So if this excess supply X0 actually goes down to 0, then these prices come down here to P3. And so producers are worse off, consumers are better off. So a couple of things I want to point out about this. More interest in the literature nowadays of not only saying, well, a consumer is worse off or a producer is worse off, but what about groups of producers and subgroups of producers, depending on where you're at and what your circumstances are, as well as producers. There can also be those that are infected and those that are not infected, but also where are you along the supply chain? So my point here is that, well, historically we thought about demand, producer surplus and consumer surplus. We probably want to start decomposing this as we move this along. Okay, so in terms of models, if I want to go and practice here, a lot of our empirical models are just simply input-output models. More and more we're seeing general equilibrium models to deal with the diseases. And then kind of the mainstay historically, at least in agriculture, has been working with partial equilibrium models. Got a little schematic over here. If you know, mainly people say recommend is if the agricultural sector doesn't necessarily affect the national income or GDP, then looking at a partial equilibrium model can be useful because you get a richer delineation of what's going along the supply chain here. Whereas if agriculture is a big part of your country level of GDP, then you may want to think about looking at a CGE type of model. In terms of ex post or post-infection models, Work by Pendau and et al. Used a model, partial equilibrium model by Parlberg to look at the impacts of a hypothetical FMD outbreak in the US several years ago, and then they used an IO model to estimate the impacts related to the spillover effects to the rest of the economy. Most recently, a colleague of mine out of Australia, Mason de Cruz, has looked at African swine fever impacts globally, and they're using a partial equilibrium model interactively with a CG model and doing feedback loops in there to get at that effect. So that's one of the more interesting steps or innovations I've seen lately. Rich et al., this is out of AGAE in 2007, uses integrated and econ models to look at foot and mouth disease on the southern corn of South America. I want to come back to that in a minute. We also are looking at some ex ante models. Briefly want to mention this. Chris Wolf and Rich Duran have, in 2015, examined dynamic epi-risks through trade between breeders and finishers. A student of mine, Perevachikov, in 2014, investigated investment and disease risk mitigation in a spatial economic model across countries. What I want to point out there is that both of these are more theoretical, but they really illustrate some equilibriums that can arise that are not what we would think of common outcomes, but are important to understanding trade and trade outcomes across heterogeneous regions. Okay, so switching gears into welfare economics, I always like to have the statement, what do economists do? Economists monetize health effects. For human diseases, this typically means using cost effectiveness with DALYs or QALYs. For animals, this is a little different in anthropocenic society, wherein animals are bought and sold in a market environment. The disability life year concept is just not easily mapped into welfare analysis. And so my argument here is that we should likely use welfare analysis and focus on benefit cost analysis, whether your criteria is benefits greater in cost to some degree or benefit cost ratio. Those can be used. So I kind of want to go to I got a real simple example here. I'm doing this on purpose. So often animals or livestock are thought of as durable goods, and so we can put them in a capital theoretic framework. And that means we have to look at costs and benefits over time. So in this simple example, I have a species K over region R over time T, and we discount with respect to a discount factor beta, and then we aggregate over space and over time to get net benefits. But one of the things I want to point out, if I look at the net benefit as benefit minus cost, and a simple model phi here is just my CDF, a likelihood of an outbreak, then and net benefits pre-infection, NB0, NB1, net benefits post-infection. I could write this as net benefits pre-infection plus the likelihood of infection times the change in net benefits post-infection. And so one of the key things here is it's really important is that we get this baseline right. And so conversations I've heard this, well, what do you do if your country is endemic? And so I think that deals directly with how you think about the baseline and how you think about counterfactuals. So some of the treatment effects literature can come in here and help delineate some of this. Okay, so characterizing costs and benefits. So I've already spoke briefly about thinking about using consumer surplus as a measure to characterize the effect on consumers, producer surplus on producers. I think that we also know that at least on the farm level, we have to include asset loss and maybe net out indemnification. We also have spillover effects to the other sectors of the economy. And then we also have the government costs. So if it's a disease or disease intervention to cleanup or vaccination, what have you. If we go to a zoonotic disease, then we have to think about human morbidity and mortality. And here's some willingness to pay values or value of statistical life. Really some econometric analysis helps guide our way to putting some of those values together. I just want to point out that, you know, for example, government expenditures on animal health, that's really hard to come by, not only in the US, but across the world. So there's a big data gap there. Okay, so I'm going to put this final slide up just as a talking point. It's really an aged, it's an aged schematic. This is something that Keith Coble, Jason Lusk, Destin Pinnell, and I did really about 10 years ago. It was published in 2015, but we were looking at hypothetical outbreaks in the US of foot and mouth disease. But we used, you know, epi data that was really treated as exogenous. I think moving forward, we have to think about how do we more endogenize what's going on between our econ and in epi models. And I think this is a area of rich future research. We need to get more data on public expenditures, even private expenditures of surveillance and cleanup. I think these are important areas. I already talked about, say, linking CGEs and PE models that can be helpful. And then finally, just looking, I've been looking at some of the climate change literature, and that earlier presentation was very good, but just how do we treat uncertainty here is really important. So I think I'll stop there and let Chris and others give us some feedback on scope, content, and key gaps. Thank you.
Thank you very much, David and Tom. That was fascinating. I will quickly hand things over to Chris Wolf of Cornell University for discussant and comments. And then we'll have some questions from the general audience.
Okay.
Are you able to share screen, Chris? Or do
Yeah,
you need
I
to?
think so. Yep, hold on.
Okay.
Are we good now?
Yeah.
How's that look? Okay. Great. Thank you, David and Tom. Happy to be here today to discuss this. I think this whole conference here, kind of being in the middle of the writing of the chapters is a really good idea. An opportunity to kind of see what's going on and get some feedback and have some discussion. We should do all things that way, or maybe not, now that we all live on Zoom. So I think this is a really nice chapter. Obviously, when you have David Hennessy and Tom Marsh writing on this topic, they're two of the best researchers in the world in this area. So clearly why they were asked, and this is a nice chapter. It's coming together well, I think. So let me just make a few comments on where they're at and maybe some suggestions on some places where they might go, and maybe they're already planning to go there because, as David discussed, there's a couple sections that are in the works. And the key idea here with animal health and livestock disease economics is that economic behavior plays a role in disease transmission, right? So, I mean, we're economists, we think that economic behavior plays a role in a lot of things, but it's really not that long, I would say, that we've, as a profession of applied economists, have been looking at some of these issues. So the literature kind of has its antecedents in the vet journals and the disease work that was done there that was really very partial, and maybe didn't meet a lot of the assumptions that we normally would apply as economists. And then David Hennessy correctly points out there the McInerney model in 1996, which that whole discussion by McInerney, which is really worth reading if you haven't done it, is kind of motivated, I think, by the fact that the veterinary literature to that point that had tried to deal with the economics of disease and animal health kind of missed the point from an economist point of view, right? The way the question was framed in wasn't necessarily the way we would like to see it framed in. And I think after McInerney in 96, then it kind of developed into more of a literature to get to where we are today. And we're talking here about things that go all the way from farmer and veterinary decisions all the way to international trade and macroeconomics in some level, the way Tom was talking about. And this involves livestock questions, it involves wildlife questions, it could involve companion animal health questions, hasn't really necessarily so much. Then there's the fact that we're talking about zoonotics, and that a lot of these diseases also have implications for human health. And so that brings it in there too. So putting kind of a boundary around this is not an easy exercise. And I think that Tom and David did a good job. So the strengths of the chapter, kind of as I see it at this point in time, is it's a really good overview. They do a really nice job of nesting the literature, right? Like as David started out with, for example, with the McInerney model, and then the Lichtenberg and Zilberman model, which, by the way, came from another literature in pest management, right? So they do a good job of kind of nesting that, and the discussion kind of goes out from there. Do a good job of kind of spanning the space, showing the interconnectedness of these animal health and livestock disease questions to human health literature, which is kind of evolved on its own. Nice discussion in there about the fundamental differences between the human health issues and the animal health issues, in the sense that both Tom and David mentioned that human health, we're thinking about quality, adjusted life years, or some measure of that, whereas for livestock and animal health, we're mostly in the cost or profit model. And then the second thing that they didn't really bring up, but that's important and is mentioned in the chapter, is the fact that the management options obviously are fundamentally different when you're talking about animal health versus human health. And that gives us a different set of tools that we can use. So put that together, the pest management, insects, microbes, there's a discussion in there about the use of antibiotics, and I think that's important. And then you got the environmental resource economics with pollution problems, with fisheries and wildlife, which are discussed a little bit less, and then you get into trade and macroeconomics. So I just wanted to spend a few minutes talking about some potential gaps and unsettled questions that I think might be in there, and maybe they will be, especially when we get some of the other sections finished, like the case studies. One area that I think could come out a little bit more maybe is the economic epidemiology, which merges economics, epidemiology, and ecology. And certainly it's mentioned, but I think that particularly on the wildlife side, there's more there, and it could be examined a little bit more. Some of the methods are maybe a little bit different, some of the applications, dealing with multiple hosts, with wildlife and livestock hosts, or two different wildlife hosts and the implications there. And then human health can clearly be brought into that too. And there was a bit of mention about data issues. I think one of the things that kind of holds this area back in some sense is the lack of data. So what we end up doing is taking parameters from epidemiology, veterinary, human health studies, and then simulating them. And there's certainly nothing wrong with that. But if we want to think about more econometric estimation, then we're going to need to be, as economists, more involved in the data collection, working with APHIS, working with other parts of USDA and maybe other international agencies to try to get the appropriate data collected so that we can do the analysis. I know there's an intention by the authors to discuss behavioral economics, and I think that's really important. Understanding the motivations of the farmers when they're making these decisions, understanding the information problems that they might have that lead to cognitive failures or cognitive biases, especially understanding risk perceptions, both by the farmers, by the veterinarians, and other people involved in these supply chains. I think it is a big deal. You're seeing more of that at the policy level. For example, the United Kingdom, their Department of Ag, DEFRA, has a whole agency now kind of devoted to dealing with the behavioral economic ones. And I think that that intersection with livestock and animal health is, there's some of it there, and and I understand this is a review. I think it's certainly an area for future research. And there is a nice discussion of industry structure and disease dynamics, and I think that's really important. I also think there's kind of an unsettled question there where there's this kind of assumption that as farm size gets bigger and gets more in what some people would call industrialized, that has some only negative implications for disease management. And I think that they do a nice job of showing that there's in fact some positive benefits too, because the value of biosecurity and prevention becomes greater, and the ability as the industry structure changes. And so that's a good discussion there. And then demonstrating impacts, and I think that's probably what the case studies are about. Examples where economics influences management and policy and actually has an impact, I think is important part of this whole discussion. And then just let me finish up with challenges. I think, as I mentioned, incorporating behavior and social interaction is a real challenge, I think, for future research, understanding that. Tom talked about bringing in willingness to pay, and some of that behavioral and experimental, but that was part of the last chapter that was discussed. I think that's really potential fruitful area for future research here. I think probably we could have a little more discussion about the equity considerations and impact distribution of these, some of these events. I'm torn about whether companion animal health should be part of this, although I think there's an interesting possibility because companion animals are going to be managed differently, and the expenditures that are going to be done by people on companion animal health issues in some ways more mirrors the human health than it does livestock. So that's and maybe companion animal health goes with farm animal welfare, which I think of as kind of a separate topic from this myself, although there certainly are overlaps. So with that, I'll wrap it up and I'll stop my sharing so that we can have a discussion.
Very good. Thank you very much, Chris. That was very interesting as well. I had a few of the same questions myself, just wondering aloud exactly what directions you're going to go with the sort of behavioral economic piece. But I want to make sure we have enough time for questions from the audience. We have probably about 10 minutes allotted for that, if we can. So feel free to raise your hand if you have a question or comment for the authors. Okay, Jared.
Hi, this is Jared Hutchins from the University. Yeah. Thank you guys for presenting. So to Chris's point about industry structure, I was just kind of curious. I work with the dairy sector a lot, but I can see that vertical integration will play a big role. So for example, with poultry, a really vertically integrated industry, there could be an extent to which disease is controlled differently or able to be controlled differently, as opposed to dairy, something that's not vertically integrated. So just wondering what your thoughts were on that.
I thoroughly agree. And I think it shows up, if we go back to the response to national animal identification, the federal policy seeking that in the around about 2005, 6, 7. It wasn't a great success in some ways, and in particular with the beef sector, but for the more integrated sectors, it has been a success. The industry bought in quite readily, so there has been a heterogeneous response. And I think that shows up. It really depends sector by sector how that's been managed. And the other thing I'd like to say is we really don't, those questions as to what impact, whether an integrated structure really will hold together in a crisis will only, in some sense, it's so hard to get data because sometimes there's a crisis averted. You never know that there might have been an issue, and the other thing is that these crises are few and far between. So it's not as if we can do econometric analysis. Most of the work on that has been through simulation analysis, linking up some economic data with a very articulated epidemiological model. And speaking personally, I find it somewhat hard to assess such analysis because I'm not an epidemiologist. And one thing I've said this at presentations over the past 10 years, I'd really like to see a subdiscipline emerging where economists are it's happening at a slower rate than I'd like, but where there were economists that were much more familiar with epidemiological models than is currently the case.
Do we have any other questions from the audience? I noticed the one comment from Danelle Peck, USDA. I don't know if you wanted to expand on that point, but I guess I can read it for those who might not have it open. To Chris's point about the literature on livestock wildlife disease, I would add another interesting complexity: multiple disease on the same landscape, where efforts to reduce the risk of one disease can increase the risk of another, and mentions brucellosis and chronic wasting disease. Seems like it'd be a really interesting, perplexing problem. I don't know how common it is.
Tom here, David.
Yeah.
Let me just respond in just a broader context. I can't address those because I haven't worked on them, but I have worked on large projects in Eastern Africa where we're looking at multiple diseases. And the first thing I'll say is you need a very large team of really good experts to deal with that because of the complexities that evolve just to understand not only, you know, what's economically feasible, but what happens biologically. So those are good questions, and I do see some of the larger multidisciplinary projects addressing some of those issues right now. But you know, it takes a lot of resources and a lot of people to do that.
Tom, this is Danelle.
Hi, Danelle.
Hi, Tom. I'd say, you know, we just published a paper about this case study, brucellosis and chronic wasting disease. And something interesting that comes out of these multi-disease stories is that not all of the diseases affect the same stakeholder. So in this case study, you know, brucellosis is largely affecting ranchers, whereas chronic wasting disease is largely affecting the wildlife population and hunters and tourism. And so, you know, part of the complexity is that these multiple diseases create multiple utility functions, and they're not always additive. So trying to help ranchers manage brucellosis in this case actually, you know, can make chronic wasting disease worse for wildlife and hunters and tourism. So it's a nice way to bring together, right? In all of the presentations that you guys just gave, you mentioned kind of, you know, focusing on different stakeholder groups, and this is a case study that brings them all together at once and looks at the trade-offs between them.
Yeah, I like that, and thanks for articulating that better. Because one of the things I see working, we have a large project, Global Burden of Animal Diseases, that we're just initiating, and one of the issues I push are two things. As economists, we optimize, but a lot of other people advocate. So I think it's really important that we do look at the distribution of benefits and costs to our different stakeholders. So that this clearly exhibits that point. And I think that's really important. And it's one of the reasons I push doing welfare economics as one tool to understanding and potentially correcting problems as we move forward. So I thank you for that.
Great. Thank you very much. I do not see any additional hands raised. Raise them quickly if you have your questions. Otherwise, we will have a short break so you can take care of other business you need to. And we'll reconvene at the top of the hour to hear about the economics of innovation. Thank you very much to David and Tom and to Chris. This was fascinating to me. Thank you.
Thanks, folks. That was great. Julian and Phil, do we have you on now? There he is.
I'm here. Morning.
Top of the morning to you, Julian.
Same to you.
Not morning here anymore. We hear you just fine. So you are.
There as well, Chris.
Great, thanks, Phil. You're set up as co-hosts. I don't know if you have slides you want to share. You should be able to do that right now if you wish.
Okay, let's see if I can get that going.
And we'll go ahead and kick off in just a minute or so. And Greg, you're on too, it looks like. Great.
Yes, Chris, can you hear me?
Can hear you fine. And you too have co-host privileges. So when Julian and Phil's presentation is done, if you want to show slides, you're able to do that. So for those who are just joining us now, so this is the last presentation of today's installation of the AAA workshop on setting the agenda for the Elsevier Handbook of Agricultural Economics, Volume 5. We're fortunate that Julian Alston and Phil Pardey will be authoring the chapter on the economics of agricultural innovation, and they are sharing an early partial draft with us to get both to get us up to speed on recent work and the current research frontier in this space, as well as to elicit input from the broader group. The whole purpose of this workshop is to give authors a chance to present their early thoughts on what should be in the handbook chapter, and to give them the chance to get feedback from all of you who are in the audience. So we're fortunate as well that Greg Graff from Colorado State will join as a discussant. We're going to give Julian and Phil 25 minutes to provide a quick overview of the rich content from a long chapter, and give Greg about 10 minutes to offer some remarks, and then we'll throw it open to broader discussion. If you have comments or questions, please use the raise hand function that is available. If you click on participants at the bottom of your screen, you should see a raise hand option. Otherwise, we ask everyone please to keep yourselves muted so we can enjoy hearing from Julian and Phil. Over to you, Julian.
Thanks, Chris, and thanks to you and David for the opportunity to have another project to do, and thanks, Greg, for giving us the benefit of your thoughts on it. So initially, we proposed a title, Some of the Economics of Agricultural Innovation, but I've got to get this to work for me now. But the editors said they preferred this other one, and it is a very big topic and a big subject, and we're only going to do some of the subject, as you'll see, and we're choosing which parts we're going to do. As inspiration, I want to offer this famous quote from Ted Schultz from 40 years ago, saying that most people in the world are poor, and if we knew the economics of being poor, we'd know much of the economics that really matters. And most of the world's poor people, then they're living in agriculture. So if we knew the economics of agriculture, we'd know much of the economics of being poor. He went on to say some more about much of the economics of agriculture being driven by advances in the quality of people and knowledge, and a quote from Marshall, that knowledge is the most powerful engine of production, and so on. So we can conclude from this, if we knew the economics of agricultural innovation, we would know much that matters about much that matters. And it is a big, important subject, and so we're humble to be taking it on. I have another quote from Matt Ridley, which you can read for yourselves, from this book published this year. I don't know if any of you haven't read Matt Ridley. He's fun to read and thoughtful and articulate. And he's written this book, and it basically says the same things 40 years later, talking in a broader way about the economy at large. And his book has many wonderful examples telling that story. And this also is in the beginning of the book. He also says, the striking thing about innovation is how mysterious it still is. And he talks about economists even, and says we cannot fully explain why it happens, let alone why it happens, when and where it happens. And we see the subject also this way, but we think we do understand some parts of the issue, and we're going to try to talk about those at least, and say what economists do know about these things. Partly the quote from Matt Ridley is to remind me that one of the things Phil and I have been talking about is that we're talking about how innovation in agriculture connects to innovation in the rest of the economy, and how it draws from innovation in the rest of the economy. So throughout the chapter, we have in mind that we'll be putting agricultural innovation in context of this broader subject and contrasting as appropriate the two parts of the economy. I hope you'll forgive me for reading. I'm not going to read too much, but I want to read the abstract because it's an efficient way of saying what we had in mind when we started the project, and it's evolving a little bit. So throughout history and in every part of the world, innovation in agriculture has played crucial roles in economic development by increasing farm productivity, enhancing the incomes of poor farmers, and making food ever more abundant and cheaper for consumers, while reducing the demands placed on natural resource stocks. In both rich and poor countries alike, agricultural innovation continues to contribute rich rewards in these ways, but it is widely underappreciated. Governments and markets consistently fail to do enough of the right kinds of R&D, and technological choices on farms are becoming ever more constrained. To begin, this chapter reviews the broad landscape of the economics of innovation and technical change in agriculture, paying attention to issues of attribution, the nature and length of the lags between research spending and its impacts on productivity, and various dimensions of innovation outcomes, including rates of return to agricultural research and the distribution of benefits. This sets the stage for a more focused discussion of technological regulation and its implications for agricultural innovation. In the current era, technical regulation is assuming increasing importance on farms and in the food chain, especially in the higher income countries. Whether through government policy or the actions of influential market intermediaries, ever tighter restrictions are being imposed on the technologies that may be used on farms and throughout the food chain. These public and private policies are often driven by ill-informed public perceptions, and many of the resulting restrictions are demonstrably economically ill-advised. These trends are both constraining the potential for innovation on farms as well as beyond the farm gate and inducing demand for new, more acceptable technologies. This chapter will give detailed attention to the implications of the woke farm and food policy movement and the related technological regulations for agricultural innovation. So that's what we set out to do. This is an outline of the sections of the chapter, and Phil and I have done a lot of work on various aspects of these issues, and so in part our selection of things to emphasize is driven by what we've already done in terms of our own prior art and others, and some of it we've been inspired to pursue and do some new work on some of these topics, as I'll try to explain. And what Greg has been given is a manuscript of, I don't know, about 80 pages maybe, which has our first whack at these things, and some of it's pretty close to where we want to be with the thing, but much of it is very, very preliminary. And so what I propose to do here is kind of skip through each of these topics and indicate where we're heading and give examples of the kinds of things we want to present. So this section we're talking about what makes agriculture different from agriculture, from the rest of the economy, and agricultural innovation different. And because agriculture uses a lot of land, and because it's biological technology, that's different from the rest of the economy in terms of the location specificity of the technology, roles of weather, pests, lags, maintenance requirements. So we have to do a lot of research just to stop yields from falling. That's the Red Queen effect in evolutionary biology. It's still very much a competitive industry with atomistic structure, although changing over time. And agriculture is shrinking in economic importance, although in many countries it's still important as a share of GDP and employment. And so these features of agriculture are driving the demand for innovation in ways that are potentially different from other parts of the economy for dealing with climate change, dealing with increasing scarcity of resources and co-evolving pests and diseases. In this section on historical perspectives, we want to run through from the invention of agriculture 10,000 years ago and up until the present day, how innovation has played a role, focusing more recently on this in some ways, the economics of innovation is the economic of market failure, and what government does about that in terms of intellectual property and other policy responses. And there's the relatively recent ideas of organised agricultural science and policy related to that, which is much of what we emphasise in our work. We have, as Phil's work is really the source of a lot of useful data on what's been going on in terms of investments in agricultural R&D globally, and particularly in the United States. And what we'll do in this chapter is, as much as possible, is take a global perspective, but on some of these subjects where we have more detailed information, we'll use US data. And so here's an example of the kind of thing that we'll be looking at, showing what's happened in terms of the global spending, public spending on agricultural science since 1981, so roughly 35 years, 40 years. It's roughly doubled, but the balance of who's doing the work has shifted considerably, so the high-income countries are falling in relative importance compared with the upper middle-income countries in Latin America and Asia, China and Brazil in particular. And we have, these are numbers we have that we're going to update, showing what's happening in terms of public versus private agricultural and non-agricultural R&D spending, and the share of the private and public and so on. And similarly, we'll be able to express the same things in terms of intensities of spending in the broader economy on the left, and then in the agricultural sector on the right. And they're different shapes, the scales are different. So agricultural R&D has been a larger percentage, more intensive. But then importantly, we see in the more recent period a decline in these things. If we look at the total spending over a long run series, looking since 1890, we can see some trends in the total numbers and the private and public balance. And in particular, we're interested in what's gone on recently, where in real terms, this is real 2019 dollar values. So we can see that public spending in the United States is back to where it was 40 years ago. And that's one of the disturbing trends we see in the data. And we can see the shape of those things in terms of public spending, whether it's done in the state experiment stations or the USDA, what's happening in the balance of those as well. And these are up to date as we can get. So we have lots of work we've and others have done on modelling the payoffs to those kinds of investments. And we published a book, shocking, it's 10 years ago, that very recent book. And that has a lot of this stuff in it. So for some of the topics, we'll be doing updates in terms of reviewing literature. For some of it, we'll lean on other work that's been done in recent years. So lots of literature reviews and other things. And so we've got a mix of that kind of thing, but also novel conceptual work, but also numbers like the numbers I was just talking about. This graph I'm showing you here is on the R&D lags, and this is a history of economic thought in terms of those models, and we can see that the lag structures being used in applied work modelling productivity have got longer, and so that's something that we'll be reviewing, because we want to look at that in the contrast with what's gone on in the industrial R&D literature. So in agricultural R&D, the dominant models are Huffman and Evanson's trapezoidal model or our gamma lag model, and they're both pretty long, compared with the stereotypical model in the industrial R&D literature is a geometric lag model that begins immediately when research is done. So research has its maximum impact immediately and then declines very rapidly. These are very different lag models, and so we're going to explore what their implications are for how we understand what's going on in the economy. There's been a lot of work on modelling and measuring rates of return to agricultural R&D, more than in the rest of the economy, and Phil and colleagues have been conducting meta-analysis of these things, and most recently, I think this paper is either last year or this year with Shudong Rao and Terry Hurley and Phil in the Australian Journal. And the numbers in the table, I'm not sure whether they're from that paper or another one, but we'll be having an up-to-date version of these numbers showing how people report internal rates of return. Some of them also report benefit cost ratios, and Phil and Terry and others have worked out procedures for converting them to equivalent benefit cost ratios or modified internal rates of return, so we can draw on all of that literature and reach conclusions about what's going on. And the overall benefit cost ratios are still big. Even if you look at the median, which is a more reasonable measure than the mean. More recently than that, in fact, just this month we published this report on looking at the CGR R&D investments, and that's been relatively intensively studied. The benefit cost ratio is about 10 to 1, and they've got about a 10 times as much more intensive study of their research investments compared with the rest of the literature. So we'll have that covered, and that'll be up to date. And then looking more broadly at consequences of innovation, we have lots of different measures and ways to think about this in terms of productivity or income, employment, distribution of benefits, and so on. So this spider graph is a really cool graph that shows in terms of yield growth versus area growth, where we can place different parts of the world, whether it's sub-Saharan Africa in yellow or Eastern Europe and former Soviet Union in grey, we get quite a spread. Whether their growth in production has come mainly from area growth, as in sub-Saharan Africa, or in yield growth, as in Asia Pacific. And so we can look at those things by countries of the world or regions of the world defined according to where they are or their per capita incomes. Here's another kind of figure that we call this a Rattanograph. We first saw this in Hayami and Rattan's book, and this is showing the paths of labour productivity versus land productivity for different regions of the world, and whether it's predominantly shifting in the form of labour saving more land intensive or the other way around. And so we'll be bringing that up to date. That's an old one from a paper we did in the Journal of Economic Perspectives. So we'll be bringing that up to date a little bit. And then looking at the United States, we have lots of information. We've put in some various papers and updating on the structure of agriculture in terms of what happened, how the number of farms and land grew together for a while, but then more recently we saw a big shift in terms of the reduction in number of farms and growth in the size of farms, and lots of changes in labour use. So this is showing how there was lots of, so the total labour fell from 20 billion hours to on the order of 7 billion hours over 50 some years, and there's a change in the balance between hired and operated labour and so forth. So we'll be going into that and looking at multi-factor productivity and input indexes and output indexes and other indexes of agricultural performance that are associated with productivity and innovation and so on. So we'll have all of that, and then we'll go into talking about in a bit more detail, unpacking the black box, as some people say, about what's going on in innovation. So we've just got a paper forthcoming in the Journal of Economic History where we go into these things in a bit of detail in terms of the structure of technical change in US agriculture and the productivity slowdown in the middle of the 20th century. And talk about one idea is we have this big wave of productivity driven by waves of different types of innovations like these, and we can think about, even though all of these types of innovation were going on all the time, the emphasis varied as we went over time, from initially primarily mechanical through biological and chemicals, and most recently in terms of data intensive technologies. And so we have measures like this one looking at horses and mules increasing in the 19th century and then falling as they were replaced with tractors and combines, and and how this period of really rapid adoption of mechanical innovations, tractors and so on, coincided with the period of accelerating, surging productivity growth, and then the subsequent slowdown in productivity growth. And then we can pull that apart and look at different types of innovations in more detail. So this is something that's reasonably up to date now, looking at all these different innovations. These are adoption curves and showing how these things all went on. And we've got stories to tell about. And this, you can see at the right of this picture, we've got genetically engineered cotton, corn and soybeans, and then we blow that out in this next picture and add on top of that these more recent information technology kind of innovations. And so we'll go into all of that and talk about what's going on there. And then the last bit, and if you read the abstract, you'd think half the chapter was going to be on this subject here, and we haven't quite worked out just how much we'll do with this. This is motivated a little bit by, I had to write a chapter for a fellowship for Gordon Rouser, and that drew on this paper by Gordon and Steve Sexton and Dave Zilberman, talking about the naturalist food paradigm, which I call the woke farm and food policy movement, same idea, where we've got this growing consumer demand for goods with credence attributes, and issues like obesity and food safety and so on, which are part of the food movement, which is pressing for changes in policy to address concerns they have about how food is produced and what the consequences of that are for these broad social issues. In 2019, that paper by those guys was published, as was the Eat Lancet Commission, which I think is an indicative measure of what's going on. This was a very organised and orchestrated push for substantial changes in policy, in food policy, to address issues related to climate change, resource use, and human health. And so these are the concern that I have as an economist about this is that people don't necessarily know what they're talking about, even though they have very strong views about these things. And so that even though I might agree with much of the story in the Eat Lancet Commission report, I may well disagree with them substantially about the kinds of policies they would advocate and the kinds of policies that the rest of the world would adopt as individuals or collectively because of the advice in that report. And so we have this, what I call post-truth policy problems, which is this idea that there's a lot of misinformation and ill-informed policy being made. And the example that I focus on that concerns me most is the push to use agricultural R&D as an instrument of social policy. And this is driven in particular by the food policy movement, who would advocate for using agricultural R&D to achieve some social purpose related to climate change or obesity or poverty or you name it. And as economists who understand policy and the relationship between targets of policy and appropriate instruments, you can think that through and reach the same kind of conclusions as I do, as Phil and I do. And so we can have these calamitous consequences where we're having increasingly regulation of existing and prospective technologies for reasons that may not stand examination. And we do have this chronic problem of too little investment in R&D and too late for many of the world's poor. And we have these misguided priorities coming out of this whole process of what I term the woke farm and food policy movement. So it looks like I'm just about on time. This is the last slide. So looking forward, we think about these things that are going on, and we see lots of potential for agricultural R&D and innovation in agriculture to be very valuable in terms of both maintenance research to evolve to address climate change and pests and diseases, and technological regulation where we're ruling out certain technologies for for environmental or animal welfare or whatever reasons, and there's demand for technologies that are more acceptable to replace them. So there's going to be a lot of demand for innovation. We have all these potential technologies in terms of digital technologies and genetic technologies and so on, and new foods. And so there are wonderful possibilities for innovation to be valuable in agriculture, but we have on the other side of this picture, we have these strong and rising headwinds being driven by, to some political forces anyways, and some of it's this fading R&D funding support, which has been going on for a long time, independent of the food policy movement. And then we have the rise of technological regulation for these various reasons I've mentioned. And we have these outcomes are being influenced by new sources of information through social media, where we have people who don't necessarily have knowledge or expertise guiding policy at all levels of the society. We have this food technology neophobia. We have roles played by the food industry and non-government organizations. So it's not a simple process of producers and consumers. There's a lot in between producers and consumers that are influencing the opportunities that producers have to produce things and the opportunities that consumers have to buy things that producers may want to produce. And so that's the last section of the thing, and my time's up and I'm done. Thanks, Chris.
Great. Thanks very much, Julian and Phil, for an excellent presentation. There's a lot to cover here. Tremendous stuff. Let's turn it over to Greg. I don't know if you have slides you wish to share, Greg. If so, Julian may need to stop sharing his screen.
Indeed, I do have slides here. Just give me one moment, please.
Maybe while we're waiting for Greg to load his slides, Julian, I'll just tee up some questions for your consideration once we come to Q&A. One is intellectual property and private investment. We've seen a big shift in intellectual property regimes in agriculture, especially over the last 40 years, given court cases, and it seems strongly associated with some shifts towards more private investment in digital and genetic R&D. I'd be curious your and Phil's thoughts on what the implications of this are going forward. Let's turn it over to Greg. It looks like you're all ready to go.
Great. Well, thank you. And I very much appreciate the opportunity to get an early look at the work that Julian and Phil have been doing here. They've been very productive as of late. I know this is one of multiple projects that they are currently working on, but nonetheless, a lot of fun to review it. This is an ambitious and a very challenging undertaking, as both you, Julian, and Chris have already prefaced. There are some great strengths in this chapter. The investments in R&D discussion, the payoffs and the rates of return sections. I am a bit of a history junkie anyway, and so I really find your historical and institutional contexts very interesting. And really, Julian and Phil are the right guys in many ways to be writing this chapter, as they have made tremendous contributions to the literature. And just the opportunity for them to compile their own contributions and put them into a chapter is in and of itself an ambitious undertaking. And they've certainly risen to that challenge. But indeed, as Julian already pointed out, innovation is really a sprawling set of issues. Innovation in many regards touches on almost all aspects of economics and the agricultural economy. And so it somewhat requires an innovation economist to be a bit of a jack of all trades and know something about a lot of different literatures and draw them into the discussion. And that's just really, I think, kind of the frontier on which this chapter may be challenged to the extent that it is. And in so doing, it might be helpful if we do pause to consider the audience here for a handbook chapter. I heard Chris restating in the introductions this morning about how the objectives of the handbook is to provide a review of literatures for colleagues and maybe graduate students in, I think, primarily agricultural economics, but maybe coming in from other fields of economics, and providing them with an introduction to the work that has been done in the literature. And certainly the book Persistence Pays that Julian referenced has been a real landmark in this literature in ag economics. I use it in my PhD course, and I know that many people have cited it in a variety of contexts. And it was a Herculean effort when it was undertaken. And it is hard to get out from under the shadow of such a large piece of work, but I think there are some opportunities here to move beyond that. I'd like to make perhaps some suggestions for how, from an editorial point of view, you guys might think about streamlining a little bit what's here. I'm not party to the logics behind your choices of all your sections and why you did them. What I'd highlight here is you have some really excellent discussion, but don't necessarily make it central around the market failures that plague innovation and the policy responses. I really think you could maybe float that up to providing a guiding structure to the chapter, and then have a number of your other sections follow from that. Another major suggestion that I might make is to bring together all of the historical discussions and maybe place that early on, because that provides some really good context. So your current section 8 might move up to section 3. And then the other area that I wonder is the payoffs and rate of returns discussion. Those are pretty closely related, and maybe they could be merged, I don't know. And then finally, your discussions on public policy and regulations seem a bit sprawling currently, and they maybe could be swept together in that discussion section near the end. And now let me just step through some questions or thoughts in each of the sections as you introduce them. The introduction of the chapter provides a very quick, brief definition of innovation, but it doesn't go into really any depth in terms of introducing a novice to the topic on really what we mean by innovation in economics. And of course, there's a lot out there already, but in providing an introduction to that literature, it might be helpful to bring it together in your own words. And moreover, to provide a workhorse model almost, or at the very least, a heuristic model of what is going on when we talk about innovation in the economy. I know that Phil did quite a bit of early work using Grillicus's knowledge production function, and I think that still is embedded in a lot of the returns and payoffs work that you guys have done. So maybe making that a little more central up front would help then to guide the discussion further on. Also, some explicit distinctions could be really helpful at this stage. All of these are intuitive to you. They're embedded in your chapter, but not necessarily obvious to the reader. The first is the distinction between innovation and then adoption. I think, of course, one can make the argument that the two may be fused. but I think a lot of our models treat them as somewhat separate phenomena. And I think you have, in fact, focused more on innovation, but you might need to tell us that there is an adoption literature out there. Here's where you can go find maybe some good reviews of it, but we're setting it aside in this chapter by and large. We'll make references to it. It's embedded. We don't get returns to innovation if it hasn't been adopted, but we're certainly not walking through all the varieties of adoption models that we find in the literature. So having that distinction up front, calling it out and setting it to rest would be very helpful. The second is the distinction between process and product innovation. And the reason that I find this really important early in a discussion with people is that the traditional agricultural literature on innovation is primarily focusing on process innovations, on production technology improvements, reducing costs, increasing efficiencies, increasing productivity, right? And for a very long time, we were almost presuming that product qualities, that they're commodities, and therefore consumer attributes are almost unchanged. That may be a discussion over in the food industry about introducing new products with new attributes, but it wasn't necessarily the focus of production agriculture. And I think you need to be clear about that as well. That then sets you up, of course, for this discussion about the woke agriculture movement, as you framed it there, Julian. But right now, that's all kind of just in the mix. Another distinction that I see embedded in here, but not called out and made explicit, is informal versus formal. It's going to be there in your history, obviously. It's also somewhat split even in contemporary agriculture between, on-farm practices may result in learning by doing, and thus on-farm informal innovation versus explicit investments in research and development, especially by input providers. There's also not a real clear call out about what the sectoral scope of your chapter is. After reviewing it, looks like we're pretty much focusing on on-farm production. You might want to tell us that you're setting aside downstream food industry R&D investments. That might just help people to understand. But also the geographic scope just seems to swing around. There's a lot of discussion from a US perspective, but I imagine that readers in developing countries, emerging economies are going to find a lot of this really helpful. And I know you guys are very versed in talking at the global scale, but just being a little bit more disciplined about maybe starting with a global perspective and then calling out particular case studies geographically when they arise would be helpful. Just to reiterate, I love the historical perspectives, but maybe perhaps sweep together the different occurrences of it in the current draft. If I could just pause for a moment and talk about the market failures and policy responses is really what I see as your conceptual organizing framework. You bring this up, right now it's embedded in one of the history sections, but we have a degree of public good market failures. Ken Arrow has a very nice discussion about the market failures in innovation, which you could ground this in. And then you lay out a spectrum of policy responses ranging from public provision all the way to private incentives. And the public provision, that's obviously the public investment in agricultural sciences. Over at the other end of the spectrum, we've got intellectual property rights. You had an interesting little touch on collective provision of collective goods and the work that you've done on checkoffs and things like that. What this overall seems to do is set you up very nicely for the distinction between public versus private R&D and the various ways that you handle it then. If we can figure out where the collective provision responses end up going. In your section on investments in agricultural R&D, this is again very well done, well received, and building on a lot of work that you all have done. And I'll tell you what, something I would like to request of you, if I might, because I have sought to do this several times, is to dredge back through the prior literature in order to lay out a comprehensive compilation of the Ag R&D investment estimates. Now, I know that you have this new data set, so I'm not talking about just the latest time series, but really reviewing the literature of what has been published, over the last several decades. Some of that starting with Phil's work back at ISNAR. And the reason I ask this of you guys, because you've got more command on all of this than anyone else. And so what are the numbers? And there are several different dimensions that you all have broken them out over different publications, the global versus the US, or the developing versus developed dimension, the public versus private spending. Obviously there's gross R&D, over economy-wide R&D, and then there are sector-specific spends in agriculture and in food. Sometimes ag and food are counted together in the literature, sometimes they're counted separately. Can we maybe tabulate all the various estimates that have been put out there and organize them in a way that makes it readily accessible to the new entrant to this literature? There's also a number of different sources. You guys have been a source, and Phil in particular, of a lot of the authoritative data series in this area, starting with work at ISNAR, now at INSTEP. There are still some publications coming out of IFPRI with some estimates. Of course, the ERS at USDA has also published some estimates on both public and private spending. It would be very helpful to those of us that are trying to navigate this broader set of literature to understand what is the difference between the INSTEP numbers and the ERS numbers. Why do they differ, and how should we think about that? As I mentioned, the sections on models of the payoffs and the rates of return, in my immediate first impression of this, moving through it, as I was really wondering whether or not these might be consolidated together as they're dealing with fairly similar issues. Maybe it's a methods versus results type of distinction or delineation between them. But I did find myself in trying to navigate it often plagued by a couple of questions. It might, if you could answer these in the framing of the sections, it might really help the reader. First of all, payoffs or returns to whom? If you could organize it in terms of first, payoffs to the government or the public good, and if so, how do you define that? Or are these literally returns on investment to a private investor? So in setting this up, making clear for us, when is this a public policy payoff in the public good sense of the word versus when is it really legitimately a private R&D investment decision? One way that I know some in the literature have done this, although I don't see it as clearly delineated in your discussion, is really the welfare decomposition of the payoffs. What are the welfare impacts on farmers, on consumers? What is the portion that the innovator themselves is able to appropriate as a return on investment? When are there externalities from the innovation? And quite a number of papers have laid these out, obviously, in different technologies. You have excellent discussions in here about, I'll just say time and space, but your lags and spillovers. But right now you've got separate discussions about what the industrial R&D literature does, and then later in the chapter, you then circle back around to how we deal with it now in the ag R&D literature. And it might just be helpful if you were to unify the lags discussion all in one section, both, you know, the broader industrial ag R&D, or sorry, industrial R&D literature, and then the ag lessons learned from that literature. This then brings me to the regulatory inducements and impediments. How are we doing for time here?
If you can wrap up in the next couple of minutes, Greg, please.
Okay, I'm almost there at this point. This is gets a little bit more problematic for me. Of course, the regulatory environment is really increasingly important for innovation. First, I see it kind of bolted on at the end as a reactive, responsive section of the chapter, and not necessarily integrated in with that putative workforce model or heuristic view of innovation. It seems a little bit specific or focused on maybe biotech or pesticides or animal health, and I don't see as much as you might about inducements. I also don't see this being really well connected right now into the larger economic literature on regulation. And so just wondering how maybe we should deal with it. Right now, it's a subsection in one of your main parts of the chapter. Maybe this should be in the public policy at the end. Just briefly, your section on consequences of ag innovation. I see three main categories of consequences that I would characterize as being beyond the immediate payoffs or returns. These three main categories are factor savings. Now, within factor savings, there's both the resource and environment factor savings, but then you may need to treat labor factor savings separately from that, and you probably do. You have a food security impacts of innovation, which you call the world food equation. And there it occurs to me that you don't necessarily give treatment to sort of both prongs of that equation. At least I didn't see, the chapter really wasn't developed enough yet for me to unpack that. And then you touch upon, but much is begged about talking about, because much of the public is very caught up in their imagination about innovation driving changes in industry structure. Finally, that public policy section, I can share that with you later since we need to wrap up. Let me just summarize by what I wish I really saw a little bit more about in here. First, what distinguishes public sector from private sector innovation? The two are discussed and treated separately, but it's not really ever laid out for us how Julian and Phil, you think about the differing characteristics, differing focus of public versus private, the relationships between the two. Are they complementary? What are they substitutes? Under what conditions might they be that? And in those relationships between the two, the technology transfer. When does the public sector really depend on private sector refinement and commercialization in order to ever get out there into the economy? Second, just that acknowledgement of the adoption piece of the equation, acknowledging where it fits into the process. Third, and it sounds, your discussion about the woke ag movement may fulfill much of this, but really touching on the consumer aspect of things. And then finally, I skipped over this in the previous slide, but a lot of the policy discussion seems pretty normative. You've got strong opinions that are well informed, of course, by your own history research, but there seems to be less of any systematic political economy, asking questions about, you know, kind of maybe dating all the way back to the Cochrane's treadmill perspective on who gains and who loses and why from innovation, and therefore how do they weigh in on policies supporting and advocating different innovations. And maybe helping us to understand a little bit more objectively and rationally why we see a handing off of the torch to the to the private sector or to emerging economies like China and Brazil. With that, there's an awful lot here. We could delve into this for a long, long time. I hope that just provides some fodder for discussion.
Thanks very much, Greg. That's a very rich set of comments for Julian and Phil to give some thought to. We have about 10 minutes or so for questions and comments. So if people would like to pose anything to Julian, Phil, Greg, please just use the raise hand feature in Zoom to indicate you'd like to speak. Julian, let me turn it back over to you for reactions to what Greg has said. Actually, Alan Love has a question or comment. Alan?
Thanks, Chris. I enjoyed all the comments. It's a really important topic area, and I think a really important chapter. I agree with Greg and about the discussion about the distribution of gains. I think that's very important, particularly with the changing relationship between private and public investment. But I kind of have a sort of maybe a different take on it. And one of them is a lot of the history of innovation has been what I would call forward driven. That is, it's from input supply, it's from the ag research centers and so on. But in recent years, it seems to me a lot of the innovation has been downward driven, backward driven, effectively from retailers and final food processors backward down the chain. And I wonder how that's changing the speed of innovation. And it might be, in some ways, sort of a new take. An important sort of comment about that is control of the decision making. And it seems like a lot of that kind of innovation, as well as the traditional forward one, where you sign contracts limiting your use of technologies and so on. And who has control of the chain? And how does that change your role as a farmer? You know, and the example would be poultry. There's lots and lots of lawsuits in poultry that continue and sustain themselves through time. And freedom, frankly, of choice as being an agricultural producer. I just wonder, Julian, if you guys have thought about that or might have comment. It's extremely hard to characterize and the impacts it might have. But I yet think for farmers themselves, it could be quite important. So thank you.
Great, thanks, Alan. Julian, over to you.
Thanks, Chris. Thanks, Alan. Thanks, Greg. I'm going to respond briefly and then maybe hand off to Phil, but going to Greg first while it's all up there. So thanks very much, Greg. Most of what you said resonated very well with me, and I thought, yes, that's exactly what we'd want to do. I wish we'd done that already. And some of the comments I think are probably reflecting the fact that what we really had in the chapter, and as I pointed out in the chapter itself, it was more like placeholders than what we actually planned to say. And so some of the comments are probably a little bit redundant from that perspective, but for the most part, I think it's going to be very helpful to us when we start trying to get closer to a finished product. Chris asked a question about the role of intellectual property in all this, and that connects a little bit to some of what Greg said and what also Alan said. And I think we just finished one of the things. We've been doing all these things in the last 12 months or so, many of which were connected to this. And one of them was we did a chapter for an NBER volume on innovation in the digital age, and our chapter was the ag chapter in that volume. So we're going to lean on that a bit to talk about those issues specifically, Chris, about IP. But that's something where what we have in the current version of the chapter is pretty vacuous, and so we'll try to fill that up. In response to Alan's question, I think that's a great question and something we're thinking about in terms of the role of. It's always been the case that the innovation on farms was induced by something, oftentimes downstream. but the players involved have changed. So we've got larger roles played by market intermediaries. I think that's the main point that you want us to pay attention to, Alan. I think we really should. So having said those brief things, I think I'd like to hand off to Phil, if you wouldn't mind, Chris.
Please, Phil, all yours.
Yeah, and thanks, Greg, for your as always, thoughtful feedback. And it reminds me, Julian and I multiple times have discussed with writing a chapter, not a book. And so there's a question as to, and we always have a tendency to start with a paper that becomes a chapter that ends up as a book. So we're well aware of the problem of trying to contain ourselves. But I think your suggestions with respect to the structuring are well taken, and Julian said it's a work in progress. So grateful for your feedback, and if you could share your slides with us, that would be terrific. I think just reverting back to Chris's opening comment about, which I think circles back to Alan's comments as well with respect to IP, and again, area that I've worked with you on, Greg, in terms of the IP landscape has shifted dramatically, and that has had seemingly large consequences for the balance of public and private effort, say between genomic innovations in the public and private sectors. And that process has largely played its hand out, not entirely, across multiple commodity lines within agriculture. But the shift to sort of this new wave of innovation that's very data-centric is in part also driven by much of the same fundamental forces, that we've actually got a significantly expanded concern, if you will, not necessarily regulation, engaged with respect to data. But now it's not just conventional IP, but there's also data privacy issues, right? So you've got legal IP constraints, and to the extent that data is now a new asset factor that's playing a role in innovation spaces, we certainly aware of that. My current life is mainly spent worrying about a big informatics center here at Minnesota, and so spending a lot of time thinking about issues around access and use and the changing incentives for generating and deploying data. So I think is a major concern, and I think it gets to the point you were making, I think, Alan, too, about issues related to technology licensing. So this is related but different than regulation. So we're talking about, we have licensed use of biotechnologies, but we also have lots of data use licenses and things of that nature, which circumscribe and affect the access to and use of data that's driving sort of the sort of data-driven revolution in agriculture that's shaping up. So I think the point you raised about adoption, I mean, we are spending a fair bit of time thinking and reconceptualizing the relationship between R&D spending and its productivity and subsequent consequences, Greg. And so that, Julian touched on it briefly in his remarks, this concern about sort of thinking very hard about why has there been a sort of a sense of bifurcation between the ag and the industrial literature with respect to that R&D productivity relationship touches on, but doesn't center solely on the adoption process, but it is central to that thinking. And you're right, we're not going to, I don't think, given the space limitations, go into elaborating a large amount with respect to sort of the adoption literature, which has been handled in other handbook chapters pretty well. But point taken. So in terms of your issues about whose R&D numbers do you believe, like the perennial question which I get. So I refer you to our technical documentation up online, where we actually do a fair bit of discussion about A, what we've done, and B, conceptually and in some places empirically, why that's different than what other people have done. And so there is a gazillion choices one has to make in putting these data together. And so we've tried, we have a, 60, 70, 80 page technical documentation up online associated with our series. I encourage you to go and look through that, and that might answer some of the questions you proposed. But I think this other issue that was touched on, some of the commentary between the scope of innovation, whether it's just on farm or looking across the whole value chain. I think our intent is to look across that whole value chain, and just to flag that the R&D resources, that the R&D spending data we've got does segment between sort of ag, chemicals, and then machinery and food related R&D. And there are fundamental differences in terms of even just the investment structures and the market structures associated with, say, the ag and the non-ag parts of that investment portfolio. So we'll tease a little bit of that out in the chapter. Yeah. That's it, Chris.
Excellent. Well, thanks very much, Phil, and thanks to both you and Julian for an excellent chapter and presentation. A couple of those graphics just blew my mind away, so I'm going to have to stare at them a little bit longer. And thanks, Greg, for very helpful and substantive comments. Folks, we've reached the end of our time. If you have comments for Julian and Phil, or for any of the chapter authors you've heard today, please don't hesitate to reach out to them. The whole point of these workshops is to elicit feedback and essentially draw on the wisdom of crowds as some really eminent authors craft these next handbook chapters for this decade's volumes. We will next convene for the second half of the Volume 5 Handbook of Agricultural Economics workshop on Thursday. You should see my screen right now where I'm just reflecting the online AAEA program listing. Please note that that we start at 8:45 Central Time, not Eastern Time. So apologies to those of you who got crossed up this morning. So at 8:45 Central Time, 9:45 Eastern Time, 6:45 for those of you really hardy souls in California who plan on joining early. And our first presentation will be a chapter on gender in agriculture and food systems by Agnes Quisenbing and Cheryl Doss. So we should have a terrific set of conversations again on Thursday about chapters emergent for this next volume of the handbook. Thank you all for participating today. Thank you especially to the authors and discussants for a really outstanding job, very enriching discussions. Thanks to David Just, my co-editor of the handbook, and to those at the AAEA who coordinated all the details. Thank you to the audience for your interest and participation. Take care and have a great day, everyone. Bye-bye.